Good morning to all the participants. Welcome to Day 6 AICT STTP on Machine Learning and Deep Learning Techniques. Today, a morning session will have a talk about KNN and SVM classification techniques by Dr. NC Naveen from Bangalore. So, this talk will focus on support vector machines and artificial neural networks that are supervised machine learning classifiers. So, this session will cover the real life applications of SVM and ANN with case studies. Sir, we are welcoming you for this session, sir, Dr. Naveen, sir. So, sir. Before hand over the session to Dr. Naveen, I would like to introduce today's session speaker, Dr. NC Naveen from Bangalore. Dr. NC Naveen, he is currently working as professor and head in the Department of Computer Science and Engineering, JSS Academy of Technical Education, Bangalore. And he has completed PhD from SRM University, Chennai. His PhD thesis titled An Analytical Approach for Real-Time Intrusion Detection Using Machine Learning Paradigm. Dr. Naveen has 40 research papers in various international and national conferences and journals, and he successfully completed a project, Garbage Segregation System using Image Processing, and this is a project sponsored under KSCST 43rd Series Student Project 2020. And Dr. Naveen awarded a Vision Group on Science and Technology grant of rupees 20 lakhs per year under the KFIST scheme during 2013 to 14 for the title Hybrid Real-Time Intrusion Detection System. And he also successfully completed a project, Secure and Precise Data in a Cloud for Rural Healthcare Monitoring with Mobility during 14 to 15 under IEI R&D grant in AIDS Screen. Dr. Naveen Garu also completed an industry-sponsored project from GE Global Research in collaboration with RVCE on deep learning models for named entity recognition. And he also have the industry exposure, and he worked as a corporate trainer for induction batches for Wipro, Tata Elxsi, SAP Labs, Saber Holdings, and faculty for MS Bits Pilani. Dr. NC Naveen has research areas includes machine learning algorithms, data science, big data analytics. We welcome you, sir. We welcome you for this session, sir.
Thank
Dr.
you.
Naveen, sir. Yeah. I would
Thank
like to invite you to take over the session on KNN and SVM classification techniques, sir. Thank you
Yeah.
for
Thank
accepting
you.
our invitation and delivering this talk. Yes, sir, you can continue, sir. Thank you.
Yeah. Uh, Maybe, ma'am, you may have to stop presenting so that I can start.
Sir?
You may have to start presenting.
Yeah, sir. Yeah, sir.
Yeah.
I'm stopping my presentation.
Yes. Is it visible?
Yes, sir.
Sir, yeah, sir.
Okay. Good morning, everyone. And first of all, again, thank you very much for a warm welcome and also asking me to give a session on support vector machine and KNN in this faculty development program. And as all of you know, since it is a faculty development program, maybe as faculties, one is our teaching, which we may have to look into how we can teach this SVM and KNN to our students. The second is research scholars who wants to work and again take further with these two methods. Maybe since it is my tail end session that I am handling on this specific topic, definitely I feel most of the advanced topics compared to SVM and KNN has already been done in these sessions by eminent experts and speakers. How I want this to go ahead is I will try to give a very high level introduction of a support vector machine and a KNN with algorithm, and also let you know how we can take it further to apply these in our research areas, whoever research scholars over here, and maybe the different other techniques that are available where you can look other than support vector machine, what is there for you and where exactly research is happening and which area the research is happening. So just to introduce myself again, as it was said, my work is more towards healthcare. So in healthcare, what was happening is earlier people used to work on a specific disease, like maybe it would be a cancer or it would be diabetes or XYZ. But what is the current trend is happening is hybrid diseases. What I mean by saying hybrid diseases is if a person is suffering from diabetes, how more prone is for cancer. A person who is obese and also diabetes, how more he is more for cancer. Now, if you just take up this, why I'm taking this example is, if I take only your cancer into consideration, typically I call it as a one dimension because most of the work that you are trying to do is related to cancer. But if I say a person who is suffering from diabetes and also cancer, I say it is a two dimension because you are looking from a perspective of diabetes data and also cancer data. Like if I say obese, then it becomes a three dimension because again I am adding one more dimension to your specific data set. Now imagine the data set that you are trying to get, the features that you need to select, the prediction model that you need to build, or it would be the classification model that you need to build, or it would be the clusters that you need to build. Now, as and when I just go on adding my data set, one is my data set, the next is the features. Once I go on adding, somewhere down the line, the actual research challenge, what all of us are facing is, how scalable are your machine learning algorithms are. So if it is working for one, will it work for the second? Because if we are looking into the hardware aspect, we are currently in a trend of we do not have any problem related to your hardware devices. Now we are having GPUs, high-end GPUs, cloud technologies has evolved. Next, we are having our storage space. We are not at all having problem, which means to say my submission over here to everyone is, let us start working on big data. So once we start working on big data, definitely maybe the earlier algorithms that you have studied, that would come handy compared to our support vector machine and KNN, because this, if you see the schedule or the way how our machine learning algorithms are taught, normally this comes at the very beginning stage. Why we are calling it as a very beginning stages? These are all predominantly used machine learning algorithms for initial stages of your work, just to find out how your data set is distributed, what feature set you need to select, and how exactly or which specific algorithm is preferable for you. Now, let us just go ahead with what is this SVM and all. So as all of you know, support vector machine, which normally we call it as SVM, this was released to statistical learning theory, which is completely related to statistical problems, which was introduced in the year 1992. This is a popular, this became more popular. Why? Because initially they started working more towards handwritten digit recognition. Now coming to SVM, normally it works very well if we are working with our information retrieval projects. Maybe it would be a text classification and all. There definitely SVM is very popular, and initially everyone will have this algorithm implemented and tested with the different what do you call parameters that they are looking for. Now if you just see here, 1%, I can say it is almost 1% test error rate for SVM. Now this is the same error rate of a carefully constructed neural network. This is what I was saying. As the research scholars, normally what we do is we need to compare these algorithms, and we have seen here the error rate of your SVM is far ahead compared to our neural network. Now SVM, this is now regarded as an important example of kernel methods. By this time I hope all of you would have heard this. We are not talking about the operating system kernel, we are talking about the machine learning algorithm kernels. Maybe all the questions that we are having, we will push it to the last. So the kernel trick is the one, normally that is the term what we normally use. The kernel trick is the one which fine-tunes your specific framework that you have designed. I will be sharing these slides to all of you. I have given very good references. Please look into these basic papers that are available to you, and this will give a very good what do you call basics, and again foundation of how this SVM could be taken further. Now let us start off with what are these SVM for. I think by this time, I think you would have heard a lot many things. And again, coming to machine learning algorithms, we broadly classify into three. One is going for your association rules. Next, we go for your classification methods. The last but not the least is your clustering method. Now, I do not again want to go again and again with these association rules. As all of you know, it is something like giving you item X to item Y, which most of us have taught, or whoever has taught data mining, definitely we would have taken this example, the market basket analysis, which we normally call as a person who purchases bread also purchases butter. So these two go hand in hand. Now, are there any chances that you go for some interesting patterns? The interesting patterns are the one which gets generated with our association rules. There we speak about something like support, confidence. These are the parameters which we look for. Coming to classification, there is a training data that is available, which is purely called as a supervised learners. We give them some training. Depending on the training that you are giving, definitely we go for classifying these depending on whether it is a class A or class B. Again, why I am taking it as class A or class B is normally we call them as binary classifiers. Initial work that we tend to do, we normally go for binary classifiers. So we will not have more classifiers which are involved in our data set. And hopefully by this time, many of you would have implemented this. Because of the time limit, I may not be able to demonstrate the working code of this SVM and KNN. But if you just Google through, many codes are available depending on the comfort level that you are having with the language. I can have SVM with your Java, I can have SVM with Python, or implementation of SVM is also available. So I will leave it to you, depending on what exactly you want to work, the tool that you need to use and the programming language that you want to use. SVM algorithms are available on hand. So just Google through, or in the GitHub, codes are available to you. Now, coming to this specific slide, what we are talking about, the linear classifier, we will come back. Now, assume that I have a data set which has been distributed in this manner. It is a 2-dimension. Maybe I can take something like height and weight, height in the X direction and weight in the Y direction. Once my data set is distributed like this, and there is an unknown pattern that has come, and anytime I want to predict which class it belongs to, this is where all our classification models comes into picture. So what exactly our classification model does is nothing but first it learns. Now again we will go back. What is the challenge that you get as a research scholar when you want to have a binary classifier? Since I said, hello. There was some disturbance, sorry. Yeah. Since I said it is a classification model, so can anybody tell what exactly a classification model is? And I use some terms called as training, testing, and all. What are the research challenges that you get when we are going for a classification model? That is my first question. The second question is, what do you mean by a classification? Anyone can answer?
So classification means separating the classes.
Okay. Fine. Maybe please don't feel bad. Why I am asking this question is, these are, yes, general questions. Yeah, maybe Vijay or somebody said that it just classifies. Now, how will I teach this to a student who doesn't know anything? So in that manner, I need. What do you mean by classification? When will you use it? So that a student will appreciate, because coming to association rules, it is pretty easy. Association rule, to teach them, it is pretty easy, because I can clearly say a person who is purchasing item X also purchases Y. It makes sense. And lot of real-time examples are available for us. Maybe we will just go ahead with Amazon, taking as an example as a retail chain, or it would be a Big Bazaar, or it would be Myntra. So that real-time example will come handy to a student, and whatever that we tend to teach, that student will understand, yes, this is what we mean by saying association rule. Now, once I start as a classification model, which is another module that we are having, which I said it is a supervised model. In supervised model, there is a training data and there is a testing data. This I have said. But how will I make sure that the student will understand What am I talking about? A classification model. That is what I am interested in to know from all of you.
Sir, myself Banusri, sir. I would like
Yeah.
to explain, sir.
Yeah.
Sir, given a specific information, this classifier or a computer should be able to differentiate whether this data belongs to which class, saying
Okay.
that the classes or groups into which I have differentiated before itself by training the machine. Given
Correct.
a new information, the same machine should be able to keep this item into one of the box or one of the classes.
Correct.
And that way we can explain the students to easily understand, sir.
Okay, fine. Any other answers? We will come to outlier and all because I think we are going far ahead because we are still in the basics. And please don't take it in a negative sense. I want all of you to support. That's why I'm making it a bit interactive. Whatever we know, it is something like we are just sharing our knowledge. It is not that I'm trying to teach you anything. I'm not here to teach any topic because most of you would have worked already and maybe more than me, you know about this specific topic. What I am interested in, since it is a faculty development program, and also for some research scholars who are looking for some inputs, what can be done, I just want to throw light upon that, nothing more. Okay, I will explain in a different manner. Let me give this specific example. I want some feedback from all of you. Now I will give you 3 subjects: a database, software engineering, and computer networks, which by that time, whenever a student is learning machine learning subject, they would have studied these subjects in computer science field. I have given you 3 subjects: database, computer networks, software engineering. Data mining subject, within this 3, which subject it belongs to? Hope my question is clear. I have given you 3 subjects: database, software engineering, computer networks. Now I am asking data mining. Data mining, normally which subject it belongs to? Or maybe I call as a prerequisite. Which subject the student should be good in? Yeah, database. What about software testing?
Software engineering.
Okay. What about network programming management?
Computer networks.
What about cloud computing?
Networks and
Okay. What about IoT?
networks, DBMS. Software engineering might be.
Yeah, I think most of you answered my question. So we will start with the first, data mining. Many of you said database. How did you say that data mining is for database? Why did you say software testing is for software engineering? On what basis you said that network project management is related to computer networks?
So there are some underlying, formulas which will make us take a decision.
Perfect, ma'am. So this is what I was saying. All of us are already trained on database. All of us are already trained on software engineering. All of us are already trained on computer networks. There are some unknown patterns which are coming, like the way how I gave you data mining, the way how I gave you software testing, which maybe I have studied or I may not have studied. Frankly speaking, software testing was not at all a syllabus for me, neither in my BE or nor in my MTech or neither in my PhD also. Though we have done some testing, as a subject I haven't studied. But still, if you give me that subject, software testing, and once I go through with the content, maybe the table of content, I will have a fair idea to which subject it belongs to. To be frank, as humans, that is what we also did right now. But when I went to cloud computing and IoT, there were some dilemmas because it starts getting into computer networks database. Because if I go for cloud computing, it is not only for one specific subject, it is hybrid. I have multiple subjects which have been included when I want to classify. Now, coming back to my model, this is what we call as a training data, testing data, and classification model. So in the training data, what I have done is, I have already taught you database, computer networks, and software engineering. Then I start giving you some testing data like your software testing management or software testing, network project management. Either you have studied or you haven't studied, but still you are able to classify them. You are able to come out with, yes, it might belong to this. And there might be some patterns which you will not be able to tell, like the way how I gave as IoT. IoT may not belong to any of this, maybe computer networks or maybe a database, we really do not know. Then those becomes a unclassified data. So I am not able to classify on the training method. Now, the major challenge what I get is how well I have taught you. How well I have taught you. If my training is bad, then definitely your classifier will work bad. As a research scholar, what is the initial challenge that we get is, how will you train your model? What is the data set that you are trying to take? Like the way, if I have taught you from beginning, the way how I have taught you, you just follow. A simple question which I can ask is, why is 2 plus 2 is 4? Who taught you 2 plus 2 is 4? Or why is 2 plus 2 is 4? Why is 2 plus 2 is not 5? None of us are having any answers because we haven't digged too much. Our parents taught us, our teachers taught us 2 plus 2 is 4. Now we are just following 2 plus 2 is 4. By any chance, if they have taught us 2 plus 2 is 5, sorry, today we would have said 2 plus 2 is 5. Yes or no? The same thing is true. The real challenge that we get when we are going for this type of models are, first, you have to work with the data set. Check the data set that you are having. How good that specific data set is, you have to assess. Again, I won't go into the details. The data pre-processing stage, which by this time all of you have gone through with it. The data pre-processing stage is your real research that you have to put into, because if your data set goes bad, then your entire model is completely wrong, because you have trained your model in a very bad manner. That's what it means. Now, once I have the specific data set, once I train my model, then I go for classification. This is what it is. I have trained my model. This is how it looks like. There is a data that has been distributed. You can see here, there are some circles with transparent and which are blocked. Now, can you classify means what I can do is I can just draw a line. So all of you know, just that is why we are calling it as a linear classifier. So I can clearly say the points which goes beyond this are dark and beyond this are like this. Maybe an example that I can take is smokers and non-smokers. Smokers and these are all smokers, these are all non-smokers. So if I get a data somewhere here which I want to predict, I will just see whether it is going beyond this line or this line. If it is towards this line, I say he is more prone for cancer. That is what normally we do. That is what we call as a +1 and -1. Now, what is the challenge that why we are learning SVM? This again, as to repeat, many of us or all of us know about this. But what is the real challenge that we get is, this is the problem. Not the problem. This is how you can draw a line. If I give it to all 70 of us here, 70 lines I get, because every line here differentiates here +1 and -1. The real challenge is, what is the best? Which line is the best? This is where our support vector machine comes into picture. Now, if you see this, what I have to do is, you have to define a margin of linear classifier which is pretty big, which means to say, the more margin that you are having within this, it is easier for you to classify. Correct? Now, you can just see here, we will start off from this. If you see here, this is the center line that you are having, a dark line that you are having. The more you are going ahead between these lines, it becomes easier for me to classify. That is why we call as a maximum margin linear classifier. So have this margin a bit more, the more and more, the thinner it gets, these points becomes closer. So my classification becomes very difficult for me, because ambiguity will start whether it belongs here or it belongs here. Now we are seeing some points. Please go through with the cursor which I am pointing to. I have some points over here. These are the points which we call as the support vectors. The support vectors are the one which actually gives you the maximum information of saying whether it belongs to this class or it belongs to this class. And again, to repeat, this is with binary. I am talking about only two class. I am not talking about multiple class. Multiple class I will talk at the last. And this is what I said. It is a very simplest kind of SVM, normally called as linear SVM. In short, we call as LSVM. And this model is available in your most of the tools, maybe working with your MATLABs. Yes, you have. R, yes, you have. Veka, if you are using, it is available. Python codes, infinite number of codes are available to you. This is what I said. These are called as the support vectors. These are, what is the definition for a support vector is, they are the data points that the margin pushes up against, which means to say, you just go on pushing them. The more you push, the margin becomes more and your model becomes more clearer. This is what it is. And I will not go into the complete mathematical models, only because mathematics is one difficult task, and with the time that we are having, it is not at all possible. So maybe these things are pretty easy. Y is equal to mx plus c. I'm trying to make it as simple as possible. Maybe the terms that we are using is wx plus b, which, since it is a linear, all of you know that it is nothing but y is equal to mx plus c. The same type we will tend to use here. Try to draw a line which maximizes and get the support vectors. What exactly the initial support vector machine does is, given this training data set, it tries to find out the support vectors with a maximum margin. This is what is the definition for our initial LSVM. Now, once I have these support vectors, given some unknown points, given some specific unknown points, you just try to fix it with the support vector, check whether it belongs to this class or it belongs to this class. That is what it means. Now, let me just go ahead. I will come back. Yeah, I think this is what is the actual, what do you call, mathematical model that you are having. This is what it is, given your weights, and for the class, you calculate. If it is -1, I say it is for this specific class. If it is for +1, it is for this specific class. And if it is 0, I say it belongs to this specific line. Now, just to stop and again tell you where exactly we go for this text classification. I was saying that support vector machines are predominantly used in a text classification. Now, once I go for some text classification, now one real-time example if I want to take, The very first that we are going as our review comments. And initially we were talking about the movies. Now we cannot take movies because of the pandemic issue. Let me take an example of our retail chain. In a retail chain, once products are available, we tend to get a lot of review comments. Once I start getting that review comments, the review comments that I am getting, you just web scrape it, put it in your data set, and I just want to know whether it is a positive response you are getting for your product or you are getting a negative response for your specific product. That is what I call as class. So whenever I get positive response, I make it in this fashion. Whenever I have negative, I will put it in this. Maybe the numbers will tell me in a simple manner. The more numbers you are having here, I say it is a negative review. The more numbers you are having here is a positive review. Now, what is the data pre-processing challenge I was talking about us in the text classification? Normally what happens is the data that you are trying to get, that data itself, you might have these points in different manner. One simple example again I want to take is the way how we pronounce our good. So see, some people will just write it as G-O-O-D, that also makes us good. Some people make it as G-U-D, that is also for good. Now I have two data points because when I say G-U-D, that is also a positive response. When you say G-O-O-D, that is also a positive response. When I go in this fashion, because of our social media, the same word is represented in different manner. Now, if you take up our Alexa, the Amazon Alexa that is available right now, where you are going for your speech to text or your speech to some specific natural language translation, just imagine, just for one word, how many data points you are having. Now, there itself, I can go for using a support vector machine. Now, this is what I was just saying. Where is it that you are trying to classify the documents? If I say classify the documents, the way how we are working, all of us are working is, maybe today I had to give you the session on support vector machine. What is that I have done from last 3-4 days is Google. Keep Googling which are all the good videos available, which are all the good PPTs that are available. Are there any good materials available in PDF format? So I have searched a lot and I tend to download them. Now, once I tend to download them, I will download everything and keep it in my specific hard disk. Now, imagine your hard disk, maybe if I say from last 2 years, how much of documents have you downloaded, first of all? We really do not know, because as and when the time comes, we have just Googled, we have downloaded n number of materials and we have put it across. Now, once we have this scenario, I will give you a problem statement. Can you just search the entire hard disk, take out all the documents, irrespective of whether it is a video, whether it is a image, whether it is a PDF document, or whether it is a Word document, all the documents related to machine learning, put it in one specific drive. Can't you make it as a research challenge itself? Because how many documents I have to, first challenge that you get is, how many documents are supposed to be searched? Searching is fine. After you search, how will you get into the content? Within the content, how will you check whether machine learning is there or not? Why I am emphasizing more on this is, let me just give you one example. If I just go to Google and give Taj Mahal, please look into all the Taj Mahal images that are available in Google. These are the images that are available in Google. My question over here is, how did Google come to know that these images are related to Taj Mahal. How did it tag? It is not that there is one person who sits and he just tags all these as Taj Mahal. See here, sometimes what happens is, this is what I was just trying to emphasize more. Sometimes what happens is, your image may not be related to Taj Mahal, but in the text, they would have given us Taj Mahal, which means to say, it is not just text extraction that you are trying to do, or you are not just trying to do one image analysis with this. Within the image, if there is a text, that also is extracted, and it will, means here Google will tell that this is Taj Mahal, maybe this specific example that I am talking about. Now, apart from that, now what is that you have done is, initially you are talking about your text. Next, your research has started as an image and a text which is embedded in an image. The last real challenge that I tell you is, what will you do if Taj Mahal text is available within a video? So you can just see here, this has been misclassified. This is what I am saying it as a misclassification. There are some misclassifications that do happen. You can see here, we really do not know why it has been classified as Taj Mahal. The answer would be here. You can just see here, they have given us luxury hotel in Delhi, which is Taj Mahal, because they have given this luxury hotel name as Taj Mahal Hotel. Now, if they have tagged as Taj Mahal Hotel, it will take that and also it will put it. Why I am trying to emphasize this part to you is, understanding SVM is not too great, and maybe our session may not help you too much. I am trying to emphasize more on what are the research work that is happening, where research scholars can think over and try to work more. So when we extract data from video, there is another challenge. When we extract images, get text out of it, you have another challenge. And may not last but not the least, if you are talking about some handwritten images, that is another next level of challenge that you are having. If it is a simple text classification that you are having, then your research problem is very much narrowed down. You are just trying to work with some natural language processing. Now, as all of you know, or you would have heard by this time, we are not calling it as NLPs nowadays. We are calling it as NLUs, natural language understanding. So processing has already been done. Lot of processing has been done. Can you understand something out of it? So this is the real challenge, because once I have given n number of documents to you, n number of materials to you, what is your understanding level? This is what I am trying to emphasize in my session also, not going too much into these mathematical model and again explaining too much of support vector machine. Maybe to make you understand and make our student understand, so that they get interest and they start implementing mini projects or their 8th semester project. PG students, they can take it as a very good project on this. So what happens is, this support vector machine is pretty simple for them. Libraries are available. They can start implementing, as I have said. Give them this problem statement that, see, you just web scrape, Google it out, and give me this specific data. Just to share my knowledge, so when I was working in my previous college, I had given this problem statement to one of my student, saying that normally what we do is we just Google out, saying that maybe I will say slides for data structures. Let me just show you. I will just give it as slides for data structures. So what happens is, Google is having its own algorithm. Let us not think what they are doing. Maybe all of us know about our page ranking, a very basic page ranking algorithm. It just runs behind. Let us not worry. Google is having its own algorithm. He has given this data structures PPT, data structures and its types, data structures and algorithms. He gives 10 to 15 and next it goes on. See, sometimes what happens, or what we have also seen is, though there would be a very good, you can see here, stacks and queues, data structures. See, actually what happened is, this specific site was not listed to me. But after I just go through with this, I find this is one of the best website that I had. If I feel so, since this specific sites are available to you, all these sites are available to you, what I told my students are, you just go through with this, web scrape it, get the content of these specific websites. Once you get these specific website content, let us apply our own algorithm and try and again check whether we can reframe these sites that are being given from Google as per our model that we have done. So we got very good results, to be frank. So we got very good results because Google was giving in one specific direction, and the way how our students were looking for data structures, once we reframed these links, and typically it was not too many links, we just took the first 100 links. We did our work only on 100 links that we had. And once we reframed these specific links, actually, once we gave it to our students, they gave very good feedback. They said, yes, sir, I think whatever has been reframed from your model, our students are getting very good links compared to data structures. See, these are the ones which makes our students and also our teaching methodology pretty interesting for students so that they can start working. Because as all of us know, we are not pure mathematicians, and we may not like too much to go into too much of maths. Again, I'm not saying without maths we can't do, whether you are interested or not. Once we are in machine learning algorithms, our statistics, probability and mathematics, we should be strong. Until unless we are strong, definitely machine learning algorithms cannot be implemented in a very good manner. But we can't go into too much of details at one shot. But these are the things which makes our students pretty interesting. If we teach support vector machine at a very basic level like this, ask them to do some projects of this sort, definitely it will instigate interest in our students. And these things, let me tell you, this will not take much time. And these are not out of the box. So once I gave it to my students, I think within 3 or 4 months, they came out with a model. And as all of us know, once our students get interest, they go way away. And they really do more than what we expect. So just wanted to share this part related to support vector machine. Please, I will pause for some time. If any feedback you want to give, please give it. And if I want to change the way how I am doing, you can just let me know, because if these things are already covered and if you feel the same things are repeated, let me change the way how I am taking the session. I expect your feedback. Hope it is fine.
Yeah, sir. Participants, you can unmute yourself, and if you want to convey anything, you can.
Yes, sir. Good morning, sir.
Yeah, good morning.
We discussed about linear classification. In which category we go for non-linear classification?
Yeah, I have the slide. I will be discussing that.
Okay, sir. Okay, thank you.
Yeah, I'll be doing it. Maybe in another 5 minutes, we will start off with nonlinear.
Okay, sir.
Yeah. Any other feedback? Hope the pace is good and I'm not covering what has already been covered, because today is the last day. I understand. And definitely all these things would have already been covered. Yes. Anything is fine. Thank you. Yeah, please be interactive. Definitely, since I'm also a faculty, I know how difficult it is to sit for these sessions and again keep listening. If you give some feedback, maybe I can fine tune, or I will just try to complete as I have planned. Hope it is fine. Okay, I will continue since I didn't get any feedback. Fine. This is what we had discussed. Maybe I will not go point by point. Support vectors. These are the data points which are nearest to the hyperplane. Now we will go for hyperplane. What exactly it is, what it means. So points of a data set that if removed would after the position of the dividing the hyperplane. Now this is what I said. These are very critical elements for a data set, because the support vectors are the one which are very critical to classify your specific model. Now, a line that linearly separates and classifies a set of data with two classes we just saw, which is pretty easy for us, where I just drew a line and I said if it belongs here, if it belongs there, these are the one these are the classes that it belongs to. Now the real question comes when we have non-linear data that is being given in a specific data set. What is this non-linearity that I am talking about? This is what maybe one of person asked right now. What happens if my data set is jumbled? So if you can see the screen over here, the screen over here will, I cannot draw a line. It is not at all possible. Now, what exactly SVM can do, or what exactly we can do initially is, can I make this two-dimensional data represented as a three-dimensional data? This is what. In order to classify a data set like the one above, it would be necessary to move away from a 2D view of a data to a 3D view. Can I move from a two-dimensional data to a three-dimensional data? Once, if you see here, since I go for a three-dimensional view, now it is possible to divide. You can see here. But in a three-dimensional view, I can't have a line. There is no possibility of having a line. What SVM does is, it draws a plane. If you can see here, it just draws a plane. Once it draws a plane, now it is possible to differentiate these two classes. Now, once I go for a three-dimension also, there would be chances that it would be jumbled again. Then is it possible to go for a four-dimension? Definitely, in our screens, it is not possible to represent a four-dimension. What is that happens if it is non-linear? Maybe I will just go ahead. Yeah, we will come here. If you see here, what is happening is I have a data set, blue lines and red. I can have a line, correct? Once I have a line like this, it is possible to say there are some blues and there are some reds. Now, once you have something like this, which is a mix, and I am talking about a line, you can think that this is a one dimension. Since it is a line, I am calling it as a one dimension. Please see the first figure. It is easier for me because if I draw a line, I am able to differentiate red, I am able to differentiate blue. This is the line that I say I am making it as center, so that it is equidistant from red and equidistant from blue. This is the one, because if I come more near to this, there are chances that it starts misclassifying because more number of points will come here. Now, this is one what we have done. Now, these are called as the support vectors. The first 2 points that you are having, this is the point which actually says this is red. This is the point which actually says that it is blue. Now, if you see the second, what has happened is this red is being mixed up in the line, and I am not able to draw a line. You cannot have a line here because more number of misclassifications will have. Instead of this, is it possible to go for a 2-dimension? Now, if you see this, if I elevate this points to a 2-dimension, draw it as X and Y, now there are chances that I can draw a line. Please go through with that. I am saying there are chances. There are chances that you may draw a line. Because I have drawn, it is possible in a 2-dimension that I can draw a line. I have 2 support vectors for red and I have 1 support vector for blue. Now, by any chance, if it is not possible in my 2-dimension, can I go for a 3-dimension? So, in general, what happens in your support vector machine is, the general idea is, which I have shown here, the original feature space can always be mapped to some higher dimensional feature space where the training set is separable. Again, as I am saying, mathematics is a bit a problem now. Linear algebra we may have to go through. That part I am skipping, which I will, if time permits or slides are being shared with you, which definitely you can go through. Please see here, if it is in this manner, I am not able to differentiate. What I do is, I will transfer into a higher dimension. Once I make this 2-dimension into 3-dimension, yes, it is possible with this plane. Above this plane are blue, below this plane are red. This is what happens in our support vector machine. The first phase in your support vector machine is, it first tries to draw a line, tries to get the support vectors. By any chance, if it is not possible for that to differentiate, which means to say it is not separable, then what I do is, I will just take it to the higher dimension. The more the dimensions that you are going, the more easier it is to separate. Again, the research challenges are too many over here. What would be the higher dimensions that you go for? I cannot go for n dimension. Then it becomes too difficult for me. There has to be some threshold and you have to plan where exactly you have to stop. So what exactly your SVM does is, from your 1-dimension, it takes to the next 1+1 dimension and tries to draw a plane. From 3D, if it is not possible, it will take it to the 4th dimension. There again, it tries to draw a line, draw a plane, and still it is not possible at that level. It goes on and on. It goes on and on. This is what we call as taking it to the next level using a non-linear support vector machines. I hope this is what I wanted to tell about your support vector machine. So just to understand what we tend to do with your support vector machine is, please understand, we have to identify the support vectors. Your data set should be very good. Check whether it is linearly separable. That is the first. If it is not linearly separable, take it to the next dimension and try to draw a plane. This is all the overall support vector machine algorithm that works behind. So once I complete this support vector machine, the next is our KNN. So before starting our KNN, let us just take up our neural network part. Maybe I will just give one example for your artificial neural networks part before going for K nearest neighbor. See, in artificial neural network, image classification does come. Now, once I have one specific, let me take a Jamboard, just give me a minute. Okay. Let us make it very simple. Assume that this is filled. Okay, these two parts are filled, these two are unfilled. Filled I will give +1, unfilled I will give -1. Means to say, this is represented as +1. This is represented as -1. So this is also -1. This is +1 because it is filled. Okay. Now can you give me some mathematics? I don't know what you do with this +1 and -1. Do any mathematics. Tell me whether it is horizontally fill or vertically fill or any fillings are happened, because I can give you, say this is an original image. This I will train you. Once I train you with this, what I mean to say by training is, as all of us know, once you give me an image, what I tend to do is, the filling I have made as +1, the unfilled I have made as -1. As a testing, I can give this also. This is my testing model. Now you have to tell whether it is filled here or which part is filled, or whether it is not filled. What exactly I want over here is, you have a combination of +1 and -1. Do any mathematics, apply any mathematics. Tell me, your model should be able to differentiate what is filled and what is not filled. This I will just leave it as an exercise and we will discuss at the last. Okay. Now, this would be a very good example to start off with your artificial neural networks, because this will tell you, or this will tell you about our weight, because the weight is nothing but is your +1 and -1, and how exactly your model is built with the mathematics. That is what I want. So please look into this and we will come back to this later. Now, what exactly happened is, our neural networks came into picture, as all of us know. And once these neural networks came into picture, lot of algorithms got developed. Now, before going to artificial neural networks, the KNN, the K nearest neighbors. Again, this is another supervised learning algorithm which is available to you. You can see for both regression and classification. Typically, if you see the picture, normally we say, show me your friends and I will tell you who you are. That is what is our KNN. What is this is, in our K nearest neighbors, we define K, the more number of points that you are having towards that K, I say it belongs to that specific class. It is something like this. The basic idea is, I have so much of training records. I have trained on so many birds. There is a test record. So if it walks like a duck, quacks like a duck, then it is probably a duck. That is how you will check. Normally what we do is, we check the distance, the proximity. How nearer or how far is it from my training model? What do we mean by this is something like this. Yeah, I will take up this. See here, what is happening here? The one nearest, that is why we call it as K. The more number of K you are having, you just go on including those many number of points. Now, if you see here, since it is only 1 point, whatever this X is nothing but the data point that you want to classify. Now, if you take up this, always it goes for this class only, because I have only 1 point. If I take 2 points, then this gets included, but there is an ambiguity. I do not know whether it is a plus or a minus. The data point, this X is the point which I want to classify. Now, if I take 3 neighbors, what is happening is I have 2 plus and only 1 minus. Now, what exactly we do in our K nearest neighbor is, if you see here, given some specific data point, any data point that you want to test, get the K number of points that are in the nearby proximity, check how close it is to those data points. The more closer it is to those data points, I classify to that specific class. This is what is here K classifier does. Now, going back, let me just go ahead with this KNN algorithm, how it predicts. The KNN algorithm will use your entire data set. It will look for K instances of the data set closest to your observation. For these K neighbors, the algorithm will use their output in order to calculate the variable Y. What exactly it does is, it just checks how close it is to those specific points that you have given with that K number. The K is the numbers that you are giving, which I showed as 1, 2, 3 and all. We will see how we select K in the coming slide. And checking the proximity, the closest distance, we have so many distance calculation functions. One simple or one predominantly used distance formula is nothing but is here Euclidean distance. People tend to use Euclidean distance, check how proximity it is, because people who have worked on clustering techniques, we have k-means. It is almost the way how we do in k-means itself. In k-means, what happens is, when we want to go for a cluster, we just go on finding the distance between those points, and then we just go on classifying that specific point. The same formula also comes over here. You can see here, this is my data. There are nearest neighbor classifiers. Go on getting the classifier. If I give 5 classifiers, I have 5 classes. So the proximity will come in this fashion. This is what is called as KNN classifier. At last, I will show you the algorithm, which is pretty simple. It is not at all difficult. But what happens is, the fewer neighbors we use, the more we will subject to underfitting the model. I think by this time, all of you know what is underfitting and overfitting. So there are chances, if I go for K value, which is very small, there are chances that my model will underfit. Or if there are too many neighbors available, then it goes for an overfitting our model, leaving it unable to generalize well on observations, which it hasn't seen at all. Because in the initial session or in our basics, we started off, what will you do if I give IoT? What will you do if you give cloud computing? This is where the problem comes into picture. The main KNN algorithm works like this. It just loads the data, initialize K. Normally, in a mathematical way, though it is a very crude way that I am telling, we just take square root of D. The square root of D is the K value that we normally take. D is nothing but the number of data points that you are having. The number of data points, square root of D becomes K for you. For each example in the data, the first part, calculate the distance between the query example and the current example, add the distance and the index of the example to an ordered collection, sort this collection of distances, smallest to largest, pick the first K entries from the K sorted collection, and in this specific K selected data, check to which class it belongs to. Maybe I have one specific example which I would like to share. 1 minute. I will be sharing this. I think I have put in the slide also. which you can use it. Yeah, this is one. Sorry, I think it is, yeah. Sorry, I am not, yeah, I think it should be here. Yeah. Maybe let me show here. This is one. I hope it is visible. See, if I take A is equal to 3, this is the point that I want to differentiate. Normally, I will differentiate into purple. And this normally in our KNN, we call it as voting. So it just go for voting. The more number of votes that you are having, it just goes for classifying to that specific class. Once my K becomes the 6, as you can see, more number of yellow points have been mapped into, and this gets classified into that specific class. And to be frank, what exactly happens with KNN is there is no much training that happens. This we will see. There is no much training happens. It directly goes for calculating this, apply this specific algorithm which I said, go for checking to which class it belongs to. Now, when we want to decide, let me tell you, there may not be any good choice, or we will not have any answers to say why KNN and SVM. Maybe with my experience, though I cannot say it is good or bad, I feel these are all very basic algorithms which every research scholar should know and he would have worked with. And normally we go for some hybrid algorithms which will give you better results compared to your SVM and KNN. As far as possible, or as far as I know, now people are not working too much with KNN because lot many good algorithms have come up, which I will be showing it in my last slide. But coming to SVM, there are again lot of advancements which has happened, which I will be telling you in the last slide, or also I will show you. And definitely it is a very good research area where a lot of you can work with. This I have told you, the number of examples in these are the first parameters which comes for you to decide which algorithm to use. What is your training data set? The dimensions of your featured space. Do we have correlated features? And do you have your underfitting and overfitting problems? Having all this, between SVM and KNN, I just want to conclude, if your SVM is linearly separable, it becomes very, very easy, and it is one of the best algorithm that you can go for. Still, if it is not linearly separable, still SVM is one of the best algorithm that you can try with. And you can go with a lot of kernel tricks. You have RBF, the radial basis function, and linear kernels. Lot of kernels are available. You please Google through with it and you can have a look. And as I said, if data is in high dimensional space, then SVM is the best, which you can see they have given very good results to work better for text classification. Normally, if you just Google through SVM, it is predominantly used for text classification. But the major disadvantages, it requires a lot of training time and normally not recommended when we have large number of training samples. Too much of training samples, too much of high dimensions you are having, it requires a lot of time. The KNN, it is robust to noisy training data set. It is effective in case of large number of training examples. But the real challenge comes to determine the parameter K and the type of distance, which you saw. We have Minkowski, we have a Euclidean distance. The next challenge comes which distance method you will use. that you may have to look into. And here also KNN, it takes a lot of time for computing the distance, because for every, if your K increases, the number of data points increases, and definitely the time that it takes for computation increases too much. And I'm sharing the resources for today's lecture in my slide. Please go through with us, which gives you a very good introduction to all this. So for my conclusion, what I want to tell, KNN keeping it separate, which is pretty simple, and understanding is simple, implementation is pretty simple. Coming to SVM, as I said, at a very basic level, you can definitely start with SVM. But what I, with my research and with my findings, I have found is the very first is relevance vector machines. I don't know whether you have heard. Has anyone heard about it? Relevance vector machine? Yes? Yes or no?
No, sir.
Yeah, please note down. Please look into relevance vector machines. Okay, so I think I had downloaded, 1 second. Okay, anyway, let me just again check. Yeah, I want all of you to look into this. Maybe I'll just give this slide. I'll put it in the chat. Yeah, I think, sorry, I didn't see. Exactly. I think Srinivas Rao sir has told. I have given you this. This also, lot of work is happening. One in a very what do you call, to tell support vector machine. What was happening is it just goes for classifying your model, saying that it belongs to class A or it belongs to class B. Now, this was bit rigid. Rigid in the sense it just says that yes, it belongs to this class because this is what is the finding that I have found. But as a research scholars or for our research, normally what happens is we want some predicted models. That is why I think Srinivas Rao sir has put up there that Bayesian inferences that comes into picture, as all of us know. You can see there the Bayesian inference that gives the probabilistic model. So what exactly happened with your RVM is, instead of going with a specific, what do you call, rigid answers, when you need probable formulation, which we call as probabilistic model, the best that you can look for is relevance vector machine. And to be frank, very less work has happened. Lot of less codes are available with relevance vector machine. And by any chance, if you have already identified your problem statement and if your data set is ready, applying relevance vector machine will definitely give you 1 or 2 very good solutions for your problem statement. The next is, we have one more. You can just note down, which again I will be sharing in the with the team, called as import vector machine. I don't know how many of you have heard about this. Has anyone heard about this?
No, sir.
Yeah, please.
No, sir.
Yeah, please look into this also, import vector machine classifier, which this also you can see these data points fine. Instead of support vectors, they called as import vectors. The import vector machine shows similar results to the widely used SVM, but has a probabilistic output. Both IVM and RVM gives you a probabilistic output. When you give a probabilistic output, there are chances that you can fine tune your model. That's all. Again, let me repeat, this may be useful or this may not be useful. But still my submission over here is, if you can just look into, because if you just browse through for relevance vector machine and import vector machine, you can see on my screen itself, very less work has happened. And this has happened in 2015. And I think 2020 or 2019, very few work has happened. These are all old work which is being shown to me. And acceptance for your journals, acceptance of your thesis, or getting some very good results out of this would be helpful for any research scholar who is working. So you can have a comparison of SVM, RVM, and IVM, and definitely I feel that would be a very good work that you would have done for your research work. That is what I feel. So most probably I think I would have completed in time for the time that has been given to me. Maybe the last, I would like to thank each one of you for sparing your valuable time and being patiently listening to what I was saying. Sorry if I have repeated some part which already you know, and some people who have already worked in this research area, they may feel that it is very basics that I would have covered. But what I wanted is just to throw upon what is there. Apart from SVM, we have RVM and IVM. To start off as your research problem statement, you can definitely start with SVM and KNN as a very basic algorithms to start with. So I would like to end my session and thank you for your time, and maybe Madam and again Srinivas sir.
Yes, sir. Yeah.
Yes, sir.
Participants, yeah, now the session is open for queries. If you have any queries, you can go with.
And I will be sharing the PPT and the PDFs to you, sir. You can
Okay.
share it.
Yeah, sure, sir. We will.
Thank
Thank you for our acceptance and giving the instructional session, and also gave the scope for doing the research in this
Yeah.
perspective. Yeah, thank you for your insights of your session, sir.
Thank you, sir. Thank you very much.
Yeah. Hello, sir.
Yes, sir.
Sir, yeah.
Yeah, here I have query related to the KNN. While selecting the K, just now you told, sir, sometimes there may be chance of whenever we are going for the voting, there may be chance of the tie, right?
Chance of?
Tie, like in the sense voting, right?
Correct.
For example, if you are taking the K is 6, so total 3. Whenever the voting time, that may be chance of the tie. Tie in the sense equal, both sides. That particular classification is near to the 3-3 voting. 3-3 voting will come.
Correct.
So that time, how we can choose?
Yeah.
So how exactly we can proceed?
Miss that part. Normally, what we do is we go for odd number. We normally won't take up even, as you rightly said. I think to just tell what Srinivas sir is saying is, if I give 6 points as K and if I get 3-3, to which class it classifies to? Hope this is what you were asking, right?
Yes.
Yeah, normally we will not go for even numbers, we go for odd. 3, 5, 7. If you see, normally the K is always selected as an odd number, not as even.
And what is the minimum and maximum of K value, sir? Actually, the confusion here, because the K is very important factor. How we can select the K?
Sir, now, this is what I said. At a very basic level, what we do is we just take square root of D, make it as an odd number, and check how you are getting the output. Then balance with either go with k as higher value or k as lower value, depending on how your values means your model is behaving. Because we will not have one answer directly for k. Like the way how we select our support and confidence in our association rule. Because it is a trade-off. We have to play around.
Okay.
Yeah, depending on the outputs that you are getting, then we will start fine-tuning it. Maybe not to confuse too much. I think all of us know about support and confidence, right?
Yeah.
In our association rule. Yes, correct. How will you select? Should the support be less or should support be more? Initial, I am talking about. The support count. Yeah, somebody said less. Means what should be the, like if many of you have worked with the data mining, normally we give 50% or support count as 2, support count as 3, correct? See, lower the number, what happens is you may not start getting interesting patterns. If you lower the, if you lower the number, lot many patterns will get included because your support count is too less. Everything gets included, correct? If I say my support count is 2, whether it is interesting or not, everything gets included. I will take an example of here, bread and butter. So I have two items. If I give my support count of 2, bread, butter, bread, jam, all these things gets included. Then I have to make it as 3. Correct? So that the three items, if they are good enough, it is better. So what I do is I will have my support count initially as less, then try to go on increasing. If you set your support count too high, there are chances that these interesting patterns will never get included because initially it will go off. A typical example in a retail chain, if I tell you, if a person has the very first market basket analysis example that we take, saying that a person who purchases bread also purchases a diaper. This is what we went through. That interesting pattern may not get included if your support count is too high. The same thing is true with your confidence. How will I select my confidence? So should my confidence be less or my confidence be more? So why I am taking this is we will not have one immediate means answer. So this is what mathematically what you do is have your square root of d, get one odd number, apply. Check how your model is working. Then you start fine-tuning here k. So KNN and k-means work on the same principle or not? K-means is for clustering. You go for clustering that. I am talking about the distance. The methods are different. KNN is a classifier, k-means is a clustering technique. But we go for distance formula. You may use Euclidean distance in KNN or Euclidean distance in k-means also. Yes, correct. In both we are finding the distance. Okay, sir?
Sir, one more.
Ah.
For in the SVM, for the non-linear classification, how do we increase the dimensionality?
Kernel trick. I think I didn't cover up that part because of the time limit. Using your kernels.
Kernels, any transformation?
Yes, kernel transformations, which I think I will be sharing. That part I am not covering today.
That is the only way, huh?
Yes.
Okay, sir. Okay.
Yeah.
Any other specific transformation? That is the kernel transformation, huh? Or any other specific transformation available?
As for my knowledge, I'm not much aware. Maybe I also have to look into.
Okay, sir. But we will go for a transformation.
Yes.
Okay, sir. Thank you.
Thank you.
And one more query, sir.
Yes, sir. Yes, sir.
And sir, here KNN high memory storage required compared to other algorithms. How we can overcome this challenge?
Mm, to be frank, what is happening is now memory is not a constraint because of that. That is what I started off with my session. And memory is a constraint and you have to store. We don't have any other go. Your computation speed is, computation time is more. And depending on your data set, if you need that much of memory, you need it. Maybe I can say if you are going for memory constraint related work, then we may have to go with your cloud, or we may have to go with our big data platforms like your Hadoop and all. There are chances that applying these algorithms on those models will increase the performance. What I mean to say over here is, at a higher level, at application level, your KNN will work. At the data storage level and the processing level, you can go for Hadoop. Because your data processing will become faster at the Hadoop level, and at the application level, your KNN can work faster. And these hybrid methods we may have to try and test. KNN, yeah.
Any more questions from the participants end? Okay, so thank you very much, sir. Thank you for sharing your
Thank
great
you very
knowledge
much.
with us, sir. Yeah, dear participants, now let us take a short break for 5 minutes. So we'll start the next session after 5 minutes. So next to talk on applications of artificial intelligence in R&D. So this session is by Dr. E. Damodar Reddy, sir, from NIT Goa. So we'll be back after 5 minutes. We'll take a break.
Okay, Revati ma'am.
Yeah, sir.
Thank you everyone for attending and also inviting me to be a speaker today. It is my
Yes,
honor, and thank you very much.
thank you, sir.
Thank you,
It is
ma'am.
our pleasure to have your session in this STP, sir. Thank you so much, sir. Thank you so much for your talk, sir.
Thank you.
Thank you. Yeah, thank you for acceptance and
Thank
giving
you,
the
sir.
presentation
Thank
too,
you.
sir. Thank you. Yeah.
Hello, Revati ma'am.
Sir?
Yeah, I did receive the material of convolution neural networks. You shared a mail, right?
Yes, sir. We have already shared all materials
No,
from
no,
day
no.
1 to day 5.
In that I checked the convolution neural networks. What the
Convolution neural networks by
what,
Dr. G. Madhu, sir. PPT is already there, sir. Can you please go with... Have you checked, sir?
yeah, I checked actually. I didn't find
Dr.
that.
G. Madhu, no, Dr. G. Madhu, sir, session on, yeah, day 4, sir. Day 4 material.
Day 4.
Yes, yes,
Day
I
4, fourth
checked.
attachment.
Okay, I checked again. Once I'm checking, I will revert back, sir. I checked. 1 minute.
It's the fourth attachment of day 4, sir.
1 minute. Day 4. Yeah. Yes, yes. Okay, sir. Yes, I got it. Thank you.
So it was Dr. Madhu, VNR, STTP, CNN, PPT was there, sir.
Yes, yes. Okay, okay. Thank you.
Yeah, okay, sir.
Ma'am, yesterday's material also kindly post, ma'am.
Yeah, we have shared everything, ma'am, up to day 5. We shared all materials. We have shared to your registered email ID. Mohanty sir, Ramesh sir, and Sarma sir's material we have already shared, ma'am. Can you please check your mail once?
Sure, ma'am. Sure.
Yeah. Welcome back. Welcome back, all the participants. So let us take our next session on applications of artificial intelligence in R&D by Dr. Damodar Reddy sir. So we welcome you, sir, Damodar Reddy sir, for this day 6 STTP on machine learning and deep learning techniques, sir. Good morning,
Thank
sir.
you. Thank you. Good morning.
Yeah, so before hand over the session to Damodar Reddy sir, I would like to introduce our today's speaker, Dr. E. Damodar Reddy Garu from NIT Goa. Dr. E. Damodar Reddy Garu is presently working as Assistant Professor in the Department of Computer Science and Engineering, National Institute of Technology, Goa. He received MSc degree from University of Hyderabad in 2006. He received MTech and PhD degree in Computer Science and Engineering from Indian School of Mines, Dhanbad in 2009 and 13. His research interests include wireless sensor networks, cognitive neuroscience, brain-computer interface, and medical imaging. Dr. Damodar Garu published more than 120 research articles in reputed international journals and standard conferences. The publications include reputed journals such as ACM, IEEE Transactions, IET, LCO, Springer, Taylor and Francis, and Dr. Reddy filed a patent on multi-level automated security system for prevention of accidents at unmanned railway level crossing. Dr. Damodar Reddy Garu is a senior member of IEEE and IACSIT and also received several awards such as Young Faculty Award, DKIF Best Researcher Award, Asia Arab Distinguished Faculty Award, CSIR Senior Research Fellowship, and Dr. APJ Abdul Kalam Lifetime Achievement National Award, and etc. Dr. Damodar Reddy Garu is also editorial board member of several international journals. He has also published 4 books by reputed publishers such as CRC Press, Taylor and Francis. Dr. Damodar Reddy Garu has handled various administrative positions such as Head of CSC Department, Training and Placement Officer, First Appellate Authority, Senate member, AAC member, and member of Board of Governance, etc. at NIT Goa. And he also had 3 of his PhD scholars have been awarded as doctorates, and another 7 PhD scholars are ongoing. So we welcome you, sir, for this STTP. Now, I would like to invite you to take over the session on applications of artificial intelligence in R&D. Sir, please. Sir? Over to Damodar Reddy, sir. Now you can present, sir.
Yes, sir. Good morning, madam. Thank you for introducing me. Am I audible? Please confirm.
Yes, sir. Yes, sir. You can continue, sir.
First of all, I would like to thank the department and the institute for giving me the opportunity of presenting my research experience with all the participants. So today's session, we are going to talk on the motivation to artificial intelligence and various applications of this, and then we take a real-time case study on this, and we are going to learn how to use the artificial intelligence concept for various applications. So let me share the presentation. Madam, can you see the PPT?
Yes, sir.
Okay, thank you. So the session title is Applications of Artificial Intelligence. Let me briefly just spend 2 minutes time on giving some motivation for the artificial intelligence and what actually the areas and topics that you're going to cover under this broad component. So many of you know the concept of artificial intelligence when you talk about improving the machine's accuracy or efficiency when you're competing with the performance of a human. So because of this particular competition we are into, we need to understand certain subdomains without which you can't really be a good researcher in artificial intelligence. When you want to do a good research in artificial intelligence, you should be mainly efficient, very efficient at three components. One is you should be very good at mathematics, first of all. Not only artificial intelligence, you know, any of the domain, you need to be very good at mathematics. But particularly in the artificial intelligence, you have almost every topic, you need some mathematical background. So you should be very good at mathematics. And at the same time, you should be very good at computer science, mathematics and computer science. Then the area in which you are going to work upon using some artificial intelligence application. Try to understand. You are very good at mathematics. You have the very good computer science background. Then you should have some domain knowledge, the front end application which you are going to solve using some artificial intelligence application. So unfortunately, many of the researchers in the country, many, I don't mind to say many of the, including many, they are not very good at all three. Many of the researchers, they try to do preliminary research, framework type of research in the artificial intelligence, try to get some publications out of this one. Yes, getting a publication is not so difficult. At the same time, when you want to do theoretical research, theoretical innovations, increments, should be very good at mathematics, domain knowledge, and then computer science applications, computer science concepts. Unfortunately, many of the what you can say researchers, when they talk about they are having good domain knowledge, they may be good at computer science topics somewhere, but they are lacking mathematics. In such case, they can hardly do some data processing. When you have only domain knowledge, when you have computer science concepts understood a bit, you can hardly do a good data processing, but you can't be a good data science person, researchers. And some of them are unfortunately very good at mathematics and they are good at computer science, but coming to the front end background, the application part, for example, somebody is working in the maybe some medical imaging application. They're very good at mathematics, they're very good at computer science application, but they don't have much domain knowledge in medical imaging or biology, bioinformatics, and neuroplasticity and other related allied applications. So when they have no domain knowledge, hardly you can be a good machine learning researchers. You can't be a data science person. And sometimes person with good mathematical skills and domain knowledge, domain expertise, they are doing good statistical research, but because they are lacking, because once they know good mathematics and domain knowledge, they can make good statistical modeling out of that one because they have domain knowledge, they have mathematical background. But at the same time, when you are not very good at computer science core concepts, then you can hardly do statistical modeling, but you can't do a good data science application. So when you want to take up a research challenge, a complex challenge in artificial intelligence, okay, I'm not giving the introductory class in artificial intelligence, try to understand. This is very, very important. Many of the people, including, I don't mind to say some of the PhD students also, they're not good at all three domains of this. Many of them are, but unfortunately, most of the case fall into, they're not good at mathematics. Because domain knowledge hardly can be learned after spending some time. Whereas mathematical knowledge can't be learned overnight. Fine. Therefore, some person who wants to take up a challenging task in artificial intelligence, they should be very good at data science, which means they have to learn good mathematics, computer science concepts, and then the domain knowledge in which the front-end domain problem which they have selected. So without opting any of these three, you can't do a good research and you can't solve a good application in artificial intelligence. Now, when you learn thoroughly the data science concept, then what happens, we can extract information from the data in an efficient way, and then you can use the knowledge out of the information to make some decision process. That is known as your wisdom. So this is how the hierarchy happens in your artificial intelligence problem, how you started from data and extracting the information and then going for knowledge discovery, from where you are finally making the wisdom of taking a decision making process. Okay. So coming to many of the what you can say topics in artificial intelligence and then allied areas of machine learning, when talk about, mainly people are very focused on neural networks. May know why many want to do research in neural networks compared to other computing problems, computing tools like genetic algorithms and then rough sets, information sets, fuzzy logic, and then other concepts. The reason for neural networks is, see, typically when you try to solve any problem, we try to solve in three ways. One is learning and training. Other one is searching. Third is linguistic type. Try to understand these three type of computing solving problem. One is training, learning and training. You're learning some information, or you can see you're training the network, something like your neural network. And then after training, you're learning some information over the iterations of the computing model, and then getting some classification problem or some information extraction to be happen, and then you're making the knowledge discovery. That is known as your learning and training, something like that. Your neural network. You're training your neural network and then learning and then solving the problem. Second is searching, extremely searching. Extreme search is available, and then we are going to solve a problem, something like your genetic algorithms. Where in genetic algorithm, where you're making enormous search space and then trying to solve a problem with the searching process. Third is linguistic type, like fuzzy type. When you encounter such a data, you're trying to solve in a fuzzy logic manner. So any artificial intelligence problem or maybe a soft computing paradigm problem, you're going to solve using these three ways: training and learning, then searching process, then fuzzy or linguistic type problems. So mainly talk about neural networks. You know, neural networks, like I have a large volume of data, and then I can use some sample data, supervised data I consider, and I train the network and then try to get some accuracy out of that one. And then accordingly, I'll train on large amount of data and try to get. You must have seen how the artificial neuron models are evolved from the learning type of the biological neuron models. When we talk of the biological neuron model, what's happened? You should understand how the neuron functions, how the millions and billions of neurons work together to perform certain tasks. Today, we are going to take a case study on brain-computer interface and how we are going to use the concepts of artificial intelligence for some real-time applications such as lie detection, human contemplation, and then maybe IoT applications and all. Today, we are going to see many applications. So one of the important concept, you know, that's neural networks and deep learning, extreme learning machines, sequential extreme learning machine, online extreme learning machine, hierarchical extreme learning machines, and then other type of your generalized adversarial network, and then GAN models, squeeze net, fractal net. There are many type of neural network architectures are there. When you consider the medical imaging problem, when you consider the medical data, something like that, where you're going to use GAN models and then fractal net, squeeze net, resonant architectures and all those things. When you consider other type of big data analytics data, you're going to use deep learning with autoencoders and many type of neural networks. So mainly when you talk of applications of artificial intelligence, mainly using neural network, maximum like, wherever there is some kind of data for training, you can use neural network to test on some large volume of big data analytics data, and then you're going to use it for some real-time problem. But you have to understand which type of neural network to adopt for what type of data. At the same time, for example, if you take some CT scan data, lung nodule data, ultrasound data, you take some CNN models and add with some GLCM features and then extract some other features and see the accuracy. So hardly what people doing, many of the people in medical imaging related applications where neural networks can be established, people are taking some deep learning and some CNN models and then add the CNN features with some other features like GLCM and fractal net features and other, then try to use the combination of these hybrid features to see the classification accuracy. If there is accuracy improved from 90 to 95, that's all. They're just publishing a paper. Yes, such a kind of easy publication is always possible with the neural networks related problems. Why? Because there is a lot of data for training. You can train the network and you can improve the accuracy. You can propose some new activation functions and aggregation functions. There is a lot of scope in the neural network where you can use for some real-time application. Propose new activation function, propose new aggregation function, decrease or increase the hidden layers, and then when you go for deep learning, and then even see the feature extraction in the deep learning process, and then take the input level features, all those things. So when we come to neural networks part, Many of the people are more interested, fascinated for high-end neural network models such as deep learning. Now, why deep learning? First of all, tell me, have you ever thought of the motivation behind deep learning? Why deep learning is very, very important and called as a universal approximator, and why it has a very important role when there are proper features are selected to just improve the classification accuracy. How it is different from conventional neural networks and all. See, all other learning models compared to deep learning, all other learning models, with the amount of data is increased. Listen, look at the figure carefully. When the amount of data is being increased drastically, the performance of the algorithm is decreased in case of other learning algorithms or other machine learning models. Whereas in case of deep learning, it is slightly opposite. Whenever the performance of the algorithm is increasing with the amount of data is increased, what else we can expect from the algorithm? Such a kind of nature is existing in deep learning. Of course, the number of layers and the complexity slightly may increase, but computational cost we're not talking about. We are talking about the amount. When the amount of data is increased, the performance of the algorithm also increase. See how the beauty of this approximator that we have, the deep learning. So mainly when people consider deep learning architectures for some real-time problem, they simply what they do, they take some first of all, this is deep learning is suitable for mainly problems where consisting of lot of data that is unlabeled data, and then some amount of labeled data. For semi-supervised classification also you can use. So deep learning when used for classification, how people can use it efficiently, because I am not very good at neural networks, but I want to use deep learning and all. So in what way people can improve the accuracy in deep learning? Hardly increasing the hidden layers does not, may not increase the accuracy. So sometimes what these people will do, maybe you can take the input layer features extracted from some optimization algorithm like bind-spread swarm computation or any other type of optimization models. You can decrease the input features to some level of meaningful features and preload in the input layer of the deep learning architecture, and then you can compose with some stack of autoencoders. You know the concept of autoencoders in deep learning, right? Many of you, when you consider deep learning with autoencoders, okay, what basically the purpose of deep learning, the autoencoders in deep learning is what? The stack of autoencoders used for dimensionality reduction and feature extraction. So when you take certain features in the input in some layer, then the features are further refined and better features are extracted over the layers of the deep learning model in the stacked autoencoders architecture. So when you use stacked autoencoders architecture in the deep learning, you can refine better and better features. And when you want to combine this deep learning architecture with some other optimization algorithm, you can preload the features of some optimization algorithm to the input layer of deep learning, such that you can have what? Better features. So when you combine deep learning with a DNN model with some autoencoders concept, you can have the classification accuracy to be, significantly improved. Such a type of contribution hardly now. See, I've seen one of the students, what he was doing, just he was taking deep learning architecture with some autoencoder just to run some biological data. Now my question to him was whether deep learning was already there. Yes. Autoencoders were already there. Yes. Then what is the novelty? He simply mentions that DNN with autoencoders was not implemented on some type 2 diabetes data. I've checked. Yes, he was right. So that's it's a framework paper. Simply you're running deep learning with autoencoders on some biological data. Yes, I do not say it's a novel research, but you can say that it's a good framework. He has identified that deep learning with autoencoders was not implemented on a particular data set, maybe type 2 diabetes, and he has implemented for the first time and he got a paper. Yes, that's a good journal. At the same time, that do not reveal their theoretical research, because you are not proposing any changes in the deep learning architecture. You are not proposing the autoencoders concept, but you are efficiently finding a package, a good composition of this deep learning architecture with autoencoders on some particular biological data which was not composed earlier. That could be a good framework type of research where people can work upon. So many of the people work in medical imaging and other allied areas. What people do, they just run the deep learning architecture, conventional one, and then try to use on different data sets. That's a good framework type of research where people do. But what I suggest, you try to make some changes in the network such that the accuracy is improved, not just taking some random features and doing that. Okay. Now coming to other machine learning model in the artificial intelligence, what is the applications and what do you mean by learning, how the learning happens and how the statistical techniques can be used to extract the models. First of all, how the supervisor, sometimes I have limited label data and unlimited or you can say large volume of unlabeled data. Then how you do semi-supervisor classification and how the features can be extracted. And then how the machine learning model can be used for some front-end application, then how the predicting models can be developed, and how the data extraction can happen finally using the knowledge discovery. All those things we are going to use. Then we have seen the deep learning, the importance of deep learning, how they can perform first feature extraction and then classification one shot using autoencoders. The first pair are using maybe autoencoders, you can say. Deep learning, you can perform feature extraction and classification one shot where you can use the deep autoencoders concept. And you have to design only one model for feature extraction and classification. You see the beauty. Deep learning can be used for feature extraction and at the same time for classification also, something like that. Then there are some problems with deep learning architectures because deep learning usually computationally expensive. You know why? Because iterative learning happens over the iterations or over the hidden layers of the deep learning, deep neural networks. Hence, we need sometimes to normalize the network. What do you mean normalization? I don't want to have many layers in the deep learning process because it improves the computational complexity, obviously, and you have to go for weight optimization also for every layer. Therefore, people have come up with something called extreme learning machines, ELM. ELM is neural network with a single layer, but that includes many features of deep neural networks. Try to understand. It's not very conventional type feed-forward neural network, whereas this is a single layer. ELM is a single layer, not like a deep learning architecture, but includes many of the features of deep learning. At the same time, accuracy is slightly lower. If deep learning gives on some medical data, maybe 95.7, something like that. Extreme learning machine give 94 point something or 95.1, something like that. Slightly lesser than deep learning, but computationally very efficient compared to deep neural networks. So when people can use for some real-time application, they can choose the extreme learning machine in place of deep learning if the algorithm is computationally very expensive, because there is no much decrement in the classification accuracy when you go for extreme learning machine in place of deep neural networks. However, when accuracy is not a major problem, when there is slight decrement in the accuracy, then you always prefer to choose extreme learning machine in place of deep neural networks because they are computationally expensive. Which one? Deep learning, deep neural networks. Similarly, we are going to use neural network for other model like cognitive computing, which is your where you are taking some human interaction data, something like your brain-computer interface, and where you are taking data from some biological or you can say cognitive related data, something like your EEG signals and neurological data, and then use it to process for some real-time application like somebody is lying or not, whereas somebody is emotional or somebody is aggressive or not, somebody is under pressure, depression or not, somebody is emotional and all those things. What is the application of that? You can think when we can make some psychological analysis, you can use it for some patient monitoring system, virtual patient monitoring system, and then some psychometric analysis and all those applications we have. So there is a cognitive analysis. They come under cognitive neuroscience. And similarly, computer vision, you know how to deal with this image extraction and use it for some medical real-time application, for some facial recognition, and then human-centric applications and all those things. Other computer-related and CBA, content-based information retrieval application, where you can extremely train your neural network and try to extract the information and then improve the classification accuracy. Then your NLP application and something that your number plate recognition, and then what is accuracy and the real-time monitoring of the CCTV surveillance system, and then that EHLN in then transport applications and all smart transport application. You can develop a smart transport center or command control system for traffic applications using this NLP for some real-time CCTV image processing and all those applications. Then you know how the AI works and what are the things you have to understand, and many of the things already, neural networks and the deep learning process and cognitive computing, how you can use neural network architectures, computer vision, NLP, machine learning. In addition to that, we have soft computing and other evolutionary computation model, which is a component of soft computing paradigms and all those things. Okay? All those things you are going to learn and understand then only you can select a good front-end AI application. When you are very good at deep learning, it's very easy to work on medical images and other training related data. When you are very good at evaluation computation, you can conveniently work on some randomized search type of algorithms and all. And when you SWAM intelligence, network coverage, set cover, routing related problems and all. Therefore, you have to learn all these things at a very deeper level to do a theoretical type of innovations in artificial intelligence. And when we say, people say applications of artificial intelligence, try to understand. I have some applications of artificial intelligence. Applications does not fall into research domain. Here you are not doing any research in application. You are developing, you are coming across some good tool of the artificial intelligence, machine learning model, something like your deep learning with autoencoders or any other type of evolutionary computation model, rough set theory, fuzzy logic, type 2 fuzzy logic and all those things. Then making some contribution there and running on some front-end real-time data or using some these artificial intelligence model. Okay, something like self-driving vehicle. There are various applications, self-driving vehicles and all, how people are trying to make these driverless vehicles, self-driving vehicle and all those things, where you need some real-time processing. Now there's the deep learning type of architectures may not be opted because they are computationally expensive and you need real-time processing in case of self-driving vehicle. So neural networks may not be very suitable because the training is required, extreme training is required, and then real-time instances have to be trained, and then so it may not be so easy using neural networks, such a type of this. But there is a training is there, that is advantage for self-driving vehicle. But problem is neural networks are expensive, they're computing. And then we have other aviation related application, something like a closest pair problem or any other type of problem using genetic algorithms or any other search problems. Then we have finance applications, like if you take some banking data, and you can expect that you must have seen the cases of previous, some of the persons who cheated the banks and ran away with thousands of crores. So such a type of applications you can develop to predict the cases of what you can say fraudulent, that you can see who is the legitimate customer and who is like a fraudulent customer. The CIBIL score and credit score model. So you can develop high-end machine learning models and artificial intelligence paradigms to predict such a cases before it's occurred. So that is in finance. And then satellite data processing, something like your remote sensing data and other type of data where people can focus upon, have some MOU with some organizations, something like an NRSI and other organizations where they have satellite data and other type of important data, AWS data, automatic weather station data, and then have some tie-up and see what is the amount of ice that was being melted for the last 10 years and what is the scenario now, what could be the ice that is going to disappear after 10 years. All such applications using satellite data processing. Glacier movement. What is a glacier? If you take Antarctica, Arctic polars, where you're going to measure the glaciers. Glaciers is like a plates of that ice plates, something like that. What is the movement in the glacier plates? After 5 years or 10 years, how much ice is going to disappear, taking some data from satellite. That is again one of the good. But for that, you have to have some problem of identifying the data first, because the data is not so easily available there. You have to have some tie-up with some organization. But they are in also need. They are in need of finding a good data science person. If you are very good at data science, you can tie up with such organization and get their data, satellite data. They have a lot of data accessed, and then run some deep learning model, machine learning models and other models, and try to get some good accuracy and make some prediction model. Okay, now the glacier amount is something. Now after some 5 years, the glacier's movement is something like this. Then heavy industry, that computer manufacturing, something like if you take CNC machine, that CNC machine, right, that milling process, how the aluminum metal is being what you can say extracted from the milling process. So that how the milling process happens on computer manufacturing. For that, how the particular video processing image can be captured when a group of soda bottles are going under the conveyor belt, how the particular image is captured and how exactly the particular defect one is identified. All those heavy industry applications you can use by using some neural network, and then some fuzzy logic related, mainly fuzzy and neural related type of application more apted at this level. Then we have human resources and recruiting. I've already some cognitive behavior application. I've seen cognitive computing. Make some model by taking some human interaction data and make some psychological analysis whether the person is aggressive or not. You know, if many of the companies before recruiting, they are making kind of psychometric analysis to the employees before giving the offer letter. If the person is very aggressive, something like short-tempered, he may not be suitable for a jobs like call center or something, where the person has to be patient, very patient. Such a type of what you call recruiting application one can develop using the cognitive related applications. Am I audible? Somebody confirm, please.
Yes, sir.
Okay, thank you. Now, marketing applications. So whenever you are taking a data mining or data repository application, you can using some machine learning model predict if I launch a particular product, whether it would be successful or not. Sentiment analysis, where what could be the possible rate of this success rate of this product, or what could be the profit estimated, and what could be the loss and the risk analysis can happen. Then media. What you call the fake news and all analysis of the fake news media, when you call again the sentiment analysis and all those things, collection of some crucial media reports and make some analysis and get a statistical modeling. I do not say just a machine learning model, make a statistical model and then say whether somebody is going to win the election and what could be the success. It is not just an exit poll or opinion poll, it's a prediction model. Exit poll or opinion poll is not a prediction model, it's a sentiment type of model, but you can make a prediction type of modeling. And then you have the music, music in the sense, again, you can have some other, some hardware related applications you can have in the music instruments and all. Then again, news publishing and all, same type of application you can have. Online telephonic customer service, you can collect the data of these mobile networks and use it for some applications like load balancing, where the network traffic is heavy, load balancing, energy harvesting, energy efficiency, routing, and all such application. You can use this network data, telephone customer service data, where the complaints are coming heavily from there. What is the reason for that? You can make some analysis. Then some gaming applications using some brain computer interface. You can interface with your human brain and then make a virtual games by your thoughts. And then like transportation, like make a smart transportation system. We are using the same traffic lights over the years, last 20-30 years. Whatever I have seen in my childhood, the same traffic system I'm seeing nowadays after 20-25 years as well. Still, why can't we develop a smart traffic system? And even I've seen once when there is no traffic, also the signal is on and all the persons are waiting. What is the use? Why can't a smart traffic system that can see the surveillance video and see that when the traffic is not heavy, and it's a real-time shifting of the signal lights with respect to the real-time traffic scenario. Why a person has to wait when there is no traffic on the road, something like that. And then for example, there is a crime happens at some junction. In the next junction, before the person comes, if there is a CCTV surveillance system and monitoring system, by the time the person comes to the next signal, automatically the signal can be on and the person cannot move, something like that. Such a real-time alert mechanism can be established, and there are all real-time problems using artificial intelligence, isn't it? So many artificial intelligence can be everywhere. And when people say it's an area, I do not really think it's an area. It's a prerequisite for many of the research domains like data mining and artificial intelligence related areas. They are actually not research areas. In my opinion, they are the prerequisite for any research area. You should learn artificial intelligence, go for security. You can do a better security protocols, trust me. You have to learn, of course, number theory, then security, the number theory to cryptography to information security. Yes, I'm not telling you don't learn the basic core areas. Yes, but even though you learn security, information security, you will better learn artificial intelligence and machine learning model. Then you see the level of improvement. Those who take up or do research in information security, ask them to do, if they have not done the artificial intelligence course, ask them to take up the course for 3 times and see the kind of improvement happens in their research, trust me. And then there are many other applications in allied areas, like in your sister areas like electrical, electronics, and other mechanical, civil. Mechanical I've already mentioned, computer and manufacturing, CNC modeling, and then other machine modeling. How you train for optimization if there is a drilling process happening over the machine, use CNC milling on the aluminum metal. Why the metal is why the drilling that rod is going for all the way a particular round? Why not we optimize as that it will take less time for milling process? It will not go for more number of rotations, something like that. In similarly, in electrical engineering, many other applications are there. You can diagnose the electric machines and drives, what is their health, what is their behavior, what could be the failure of rate of a grid, and when the grid is expected to be failed, what could be the measures, corrective measures to be taken, and then how the synchronous control can happen over some electrical machine and some grid structures, and how the fault rate can be reduced, what is the reason for the fault rate, make some predictions, and then the power system, power electronics applications also you can use to measure the load of a grid, the real-time load, and if last year so and so time, if there is a load, and this year with respect to time, it may not be same load or even higher. Last year, if there is some load, some watts of load, and the same year again, next year same load may not be there. It is gradually growing, may not be exponentially or maybe exponentially. So what could be the estimated load this year, considering next year's requirement, and so on. So we have to add. So there are all applications in electrical engineering, and there are many problems. Please, am I audible?
Yes, sir.
Please, all of you turn off your microphone. Now we have several problems where we are going to use AI methods, and main problems is like something like character recognition or optical character recognition. Now I'm not telling this is just application. There are the challenges like your research problems, you can call it as. There are applications. Challenges to application, there is a different, slight difference. Try to understand. So optical character recognition, a research problem. Handwriting recognition, a research problem. When somebody's signature is forged, can we develop a model with 100% accuracy whether somebody's signature is forged, whether it's really true? Handwriting recognition and speech recognition, whether a speech, if somebody is imitating your voice, and there is a voice control or voice based encryption system or a locking system, something like that. Because in future, I'm sure there will be no ATM card and there will be no debit card, everything over your fingerprint or maybe iris technology or maybe other type of voice recognition based models, where you need not to carry anything. In future, maybe after 5 years or 10 years or 20 years, we don't know, but it is going to happen, and you need not to carry anything. And you will go to such a state, for example, if somebody forcibly take you to ATM and use your voice or something to that will not work at all. Such a level of research you're going to see, trust me. Try to understand. When you have a card, somebody forcibly asks you to keep your card and enter ATM, you have to enter. But when you go take your fingerprint or something as a biometric to just open the ATM or withdraw some money from ATM, then somebody can still do that because they can forcibly take you to do and use your fingerprint. But maybe voice-based recognition system. When you're going for voice-based recognition system, your sample voice is collected whenever you're in normal mode, not a tensed mode. Then your voice is collected when somebody is taking you to ATM, maybe a person who is robbing your money, taking you to ATM and asking you to open your withdraw some money using your voice recognition system. In future, whenever such technology comes, then when you are tensed and when there is some changes in your voice, okay, certainly the ATM will not work. Such a level of research one has to reach. That is known as optimization, security optimization. Okay, all such applications will have. Then you have speech recognition, then face recognition. And somebody who is making the face recognition related say encryption model for security application, if the person is not shaved for a while, sometimes the system may not work. I have experienced this. So can we have a even better accurate facial recognition system? Now here you need the concepts of deep neural networks, extreme learning machine with good activation and aggregation functions. Then you have artificial creativity, and something like you'll develop some good efficient models for some what you call some creative application, like maybe some CG application, some CG movie related application, some animated application, some kind of creativity, artificial creativity. I just give an input like I want so and so kind of animation, and various type of creative animation models will come into the picture, something like that. Then other computer vision, virtual reality and image processing, virtual reality and your distributed virtual reality for some gaming application where a group of person can play like a group of person can talk in a conference call. A group of person can play a game virtually using a VR system, VR or AR, augmented or virtual reality system. For that, again, you are in need of artificial intelligence. Everywhere it is needed. and then how the image processing, how the image capturing can happen, how the line offset can be generated, and all those things. Then photo and video manipulation, and how the photo and video manipulation can be efficiently done. And why I say efficient in the sense, in case of some photo editing and other processing, sometimes we have to make a editing process very efficiently. On the other side, when there is a duplicate image is there for a forensic application or for a crime scenario, how it is to be evaluated correctly that it is a fake image or not. Something like it is extremely useful for social image applications. Try to understand. If somebody can download your photo from Facebook or somewhere of your social networking applications, then they can, when people are trying to alter or modify the photo, manipulate the photo for some nonsense applications, where we can use it to identify that it is 100% fake image. So either ways, one like we can generate application to make a normal image to just go to a certain level of high level image with maximum accuracy. On the other side, to identify the fake images as well. Then we have diagnosis artificial intelligence. Like you just go for some collecting data of patients, type with some organization, medical organization, take the data of patients who are coming for diabetic test, take 100 patients data, and then make some supervised data, and then see how make some computation model, see whether it is type 1 diabetes or type 2 diabetes or non-diabetic. The model, first to develop a model, test on the supervised data. If you can know any unsupervised model, whenever it is evaluated on supervised data. The reason is, for example, if you come up with a supervised model like that, negative or positive, you have to first test on 100 patient data whom you know the class level attribute, the last column, that is which is diabetic or not. Then you tell whether it is 100% telling for the 100 patient, if 49 are diabetic, 51 are non-diabetic, your model should give for those 49 it should be diabetic, and those 59 it should be non-diabetic. If out of 49, 51, yours is giving 50-50, there is one error, means 99% accuracy you have, 1% error you have. So such a type of what you can say diagnosis you are going to make using some artificial intelligence prediction model and detection models. And you are going to develop such a type of model with maximum accuracy. Now, for example, you take lie detection. I have seen about 90, 94, 95% accuracy. I have not seen any 99% accuracy. Even their own benchmark data. Fine. At the same time, when you come up with these diagnosis models and detection prediction models, you should not validate only on your data. You have to validate data on multidimensional. You have to validate on different benchmark data sets. Then you have to validate your accuracy. Then gaming applications using artificial intelligence and computer game, robot applications, and then prosthetics applications and other applications. How a robotic or robo can device or act according to your application, and the gaming applications, how according to your commands the game can be proceed further. Then NLP applications and all, I have already seen the translation and chatterbots application, then other gaming applications, NLP applications you already seen. Then non-linear control and robotic applications, and then particularly this robotic in this is medical robotic applications, how a surgery can be efficiently done with the minimum what you can say invasiveness, in the sense the body cut, when you are cutting the body in the surgery, during the surgery, when you train the robotic using a neural network, first you train on some artificial body and some foreign body, then you go for existing the real-time experimentation on some maybe autopsy bodies, then go for real-time patient bodies, something like that. Okay. Then there are other fields where also artificial intelligence methods are implemented, like artificial life, automated reasoning, automation. If you keep on discussing, there is no end for that. Then biological inspired computing, that is evolutionary computation. Then concept training and this one mining, data mining, knowledge, all those things, semantic analysis, security issues. Then this have spam filtering, that outlet detection, credit card fraud detection. You know, right, all of you. Like when you have if you take credit card fraud detection data, that is if you consider data from January to December, when you consider data of a particular month, if the transaction is unusually longer, if it's 100 times more than the average transaction of the remaining 11 months, the data of the credit card, it reveals that there could be a fraud of the particular month. Maybe or may not be, but at least it could be an indication to you using the global outliers and local outlier factor, collective outliers, and then all those outlier analysis and anomaly detection in the artificial intelligence. You can use this type of problem can be solved. Not only with respect to transaction cost, sometimes all the credit card transactions are offline. All of a sudden, one transaction happens, only one transaction with unusually longer cost of the transaction. It happens in some Singapore or some internet banking, which means the card could be stolen, or maybe the details of the card were stolen using phishing or skimming process, and then it was used for some internet banking e-commerce application. Then it is a fraudulent transaction. We have to identify all such filtering methods, spam filtering and application we are going to use. Then cybernetics, some cyber physical systems applications, and then evolutionary robotics applications, and then intelligent agent applications. Intelligent agents, how you define as a particular what you can say person or something, for some efficient real-time analysis applications, some surveillance system application, and then some defense application. And then you can develop artificial intelligence surveillance system using some so and so for visual scene analysis in borders. And you can develop artificial fencing. See, you can imagine the cost of real-time fencing happens over the thousands of kilometers in the defense. So can we simply have a real-time augmented or virtual reality type fencing system in the borders where somebody can touch the virtual fencing? You'll get a real-time picture of the fencing, and then where the location there is an interruption, whether it is animal or whether it is a human. If it is a human, if it is he is a what you can say terrorist or a innocent person, by just making some, when you touch the fencing, the real-time object, you can make some what you can say, you can make some human interaction with the person of the signal, because the person is touching the signal of the real-time fencing. Okay, but that is a virtual fencing. So when a person touch virtual fencing at the defense, maybe the Indo-China border or somewhere, you can make some analysis and see. Because the moment you touch a signal means there is an interaction to the person and to your system, and make some analysis, something like that. And then some other litigation applied, and either blockchain technology for even in blockchain also people can use these evolutionary computation, because how blockchain works, decentralized security measure, right? Where people can use blockchain technology, people can use the decentralized machine learning model, something like your swarm intelligence. Swarm intelligence is purely a decentralized machine learning model in which there is no centralized control. They have only local communication to work with. So when people can work upon decentralized control security measure like blockchain technology, they can use swarm intelligence and evolutionary computation model, genetic algorithms and all, because they're also in need of searching for the finding the attackers and all those things. So just let us take a case study where we are currently doing our research at NIT Goa, where we have a brain-computer interface laboratory. So how machine learning can be used for some real-time application? Please, somebody confirm, am I audible?
Yes, sir. Yes, sir, it is audible.
Okay, thank you.
Proceed.
Now,
yeah.
Let me take a case study and how the particular applications of artificial intelligence can be seen in real time. Now, it is often the dream of a people. If you see, I want to read somebody's ATM PIN number. I want to know somebody's ATM PIN number without asking them. Is it possible? Now, all of you unanimously say not possible. Okay. Can I predict? All of you say no. Now, can I guess? No. Can I compute? Now, maybe. It's not no. Yes. Without asking him, I can compute. I do not say guess. I do not say predict. I do not say what you can say reveal. I can only what you can say compute the ATM PIN number of somebody without asking them. How? Now, where the ATM PIN is stored? In somebody's brain. When somebody's brain some information is stored, can we really interact to the human brain? Yes. Why not interact? Whenever we can interact with heart and take the data is ECG data. When we take with blood and we say that we have blood pressure data. When we can, why can't we interact with brain, and already we are collecting EEG data. Now, when we can record the EEG signal from the human brain, then why can't we analyze the signal, and how the signal can be analyzed to find the ATM PIN number of somebody? You see, I am going to ask the person 40 questions. Typically, ATM PIN is of how many digits? Somebody answer? 4 digits. Right? 4 digits. So I'm going to ask the person 40 questions, 10 questions for each digit. What is the first 10 question? what is the first digit of your ATM PIN number? Is it 0? What are the possibilities? 0, 1, 2, 3, up to so on 9. Any one of the number could be the first digit, 0 or 1 or 2, 9. So there are 10 possible chances are there. So I will ask him 10 questions. What is the first digit of your ATM PIN number? 10 question for first digit. Okay. So when I say 0, is it 0? Is it 1? Is it 2, 3, 4, up to 9? The person will not say because nobody shares the ATM PIN number. Right. But whenever we ask the question, he knows out of 10, 9 are negative, 1 is positive. If his ATM PIN number is 9, so 0 to 8, it is negative. 1 is positive. So out of 10 questions, 9 negatives and 1 positive signal will be, identified in the brain. And already we have collected some electrodes to the human brain and we are collecting the data by the step. Now, second question, second ATM PIN number, I will ask another 10 question, another 10, another 10. Now with 40 questions, then I will make some statistical modeling. I will analysis. Not very difficult, simple logic. See, somebody is laughing, somebody is crying. Okay, or same person is laughing and crying, laughing and crying, laughing and crying. For two different actions, there can be no same behavior within the human brain. You can always note that. So whenever you can ask such a question, for 10 questions, one different behavior is there. You can capture this behavior when you draw the real-time polygraphs in the some particular graph and see, okay, this digit could be there because for this digit, his thinking is abnormal. Remaining 9 digits, it is same. So if you can draw these 4 graphs aside, and I can predict, that's why I say I can compute, I can compute approximately. I can compute approximately, this could be the like 1, 2, 5, 7, something could be your ATM PIN number. All 4 may not be correct, but if you can train the subject or the person properly while recording the data, I'm sure you will, after a certain level of trials, you will be able to identify the PIN number of somebody without asking them. Do you agree? Is it possible? It may not be fully possible now at this point of time, may not be with 100% accuracy, but of course it is possible. Even when you can make a blink of your eye also, we can capture a different signal in your human brain. And wherever I have gone, I have recorded the signals in various colleges in Hyderabad. I have shown real-time demonstration. Unfortunately, this is a virtual presentation. I can't show the real-time demonstration. We have got a very good laboratory at NIT Goa, where we have a brain data acquisition system, where we are recording real-time system, real-time EEG signals and showing even a person laughing, even a person crying, even a person is blinking the eyes also, I'm showing this is the time, this is the so-and-so. Now you can imagine what is the pros and cons of such a case study. Suddenly I'll come to artificial intelligence. Yes, I'm going to use artificial intelligence. Just give me 1 second, I'll have some water. So you can imagine, if one can try to read your brain, what will happen? What will happen? And when somebody can influence your human brain, what will happen? What are the, you must have seen recently one Telugu movie in somewhere that is known as Smart Shankar, where there is a person with a brain computer interface implanted device, how the person was acting. And we have seen the real-time application of that. Of course, there is a long way to go there, but certainly the research is going with a lot of speed. Now, what could be the expectation? Just can somebody tell me what could be the real-time application using artificial intelligence when somebody can read your brain? Okay. Now, for example, in early days, there was no test required for marriage. Nowadays, before marriage, somebody wants like, I want full medical test of either whether boy or girl. I want to see the test, somebody, either sides of the families. With somebody is really healthy, only the marriage can happen. Such a type of procedures are still due. They're going on somewhere. Now, who knows, maybe in future, a psychological test may also be conducted. Like you will read somebody's brain, because I want to make it, share a small joke here. Once, whenever a boy and girl, whenever they wanted to marry, a boy went to girl's house with his family to see the girl. Certainly it's a tradition our side. Usually boys goes. I'm not against girl going to boys house first. It doesn't matter. So anyone goes. When the boys goes to see the girl's house, then the parents of the girl, they were asking the boy, or the girl is asking the boy, what's your name? Then do you smoke? Boy said no. Then do you drink? Boy said no. Then do you have too many friends? No, I don't have any friends. I always at home. Then, okay, do you have any bad habits? The boy said, I don't have any bad habits except I lie sometimes. Which means what? What and all he has told now, everything is a lie. So that's how this system is happening. Now, can you imagine if this particular research has gone to such a level of peak, what will happen? If it has gone to such a level, when a particular marriage happening, if a guy or a boy or a girl, anybody can demand, you go for a psychometric test or any other psychological test, whether you are good or not, you are aggressive or not. What is the guarantee that you will slap me after so and so days, or maybe you will be angry always? Why should I marry you? Something like that. So one can have a psychological what you can say something test and say whether the person is very aggressive, whether the person is honest, whether the person is inject and all, whether the person is really what you can say. If you want to go for another application, like who is really going to be in army or defense application, we can generate some real-time analysis application, like whether the person is really patriotic or not. We don't want somebody in defense if he's really not patriotic. Okay, such an application, not only for marriage, I can go for defense also, right? So such even when selecting for higher educations and all, students can go for some kind of intelligent IQ analysis. What is the IQ of a person? What do you mean by IQ? IQ of the person is denoted by the what you can say, or you can say measured by the brain behavior. Somebody is 7 feet or 6 feet, his IQ is high. Somebody is 5 feet, his IQ low. Not like that, right? So when somebody's IQ is concerned with the human brain, can we have a system, a machine learning, a statistical model to be developed by taking the data from the human brain? Can I identify his IQ is so and so? Because typically what and all the IQ measurements you are making, they are really not very solid in my opinion. The reason is you are asking to solve something, and based on that you are telling the IQ is something. But if while solving the question, if his IQ levels are not fully used, then really that's not a, I mean, somebody is very intelligent, they don't know how to solve a small problem. It's true sometimes. So when you directly connect the brain and taking the data and generating the IQ intelligent quotient, then you see the what you can say real-time impact, and see before recruiting to higher level education institutions, you can generate somebody's IQ, and whose IQ is really high. Only then you can recruit them for some courses or some jobs or whatever it is. There is nothing wrong in it, in my opinion. And somebody's IQ may be less now and may be very higher in future. Somebody's, who knows? And many of the average students in school level, they have got a lot of success. You know, trust me, many of the toppers, okay, if there are toppers are there, many of the toppers, okay, I've seen after the school level, during school time, many of the toppers after the school level, I've seen them, they have come down drastically. Not all, many of them. Whereas I've seen number of average students, they significantly improved. It is not because they have not consumed their brain too much in the beginning, now they are consuming. It's not like that. Okay. And it's not like the toppers have consumed their brain heavily in the early days. That's why they're not. No, human brain is very powerful. But the reason is what? Such a level of intensity we can develop and we can generate and use for some application like IQ detection, human contemplation, psychometric analysis, and then measuring the aggressiveness, concentration levels, and pressure levels. And you can have the school children to be under extreme pressure during the exam time. You can make a wearable electrode and see how this can happen. All these applications you can solve. How I can solve? When the data is in your hand, again, you go back to the starting of the slide today we have seen and come back. Now I have given all the inputs now. Now, what was our first slide? I started with data. I started with data science. So once you collect the data from the human brain, go back to first slide and come till now. That's how you are going to solve all these problems. Are you understanding what I'm telling? Now we have data you are collecting from the human brain. You collect the data. Go to the first slide where we have data, information, and knowledge, then wisdom. Then you come back. Use all the machine learning model, genetic algorithms, family intelligence, deep learning, extreme learning machine, all that we have seen. Then by the time you come back, you will have your application and a good paper in your hand. Okay. So anyhow, these things all you know, which is a biological neuron model, how it behaves, and now we have no much time to see all those things. So I'm just ignoring them. Just a case study I'm taking because we are doing good research at NIT Goa on this particular human-computer interaction. You have to understand what is called this basic structure. Now, I have mentioned the first slide, there is something called domain knowledge. Now, you will understand. See, you are very good at mathematics. You're very good at computer science, but you don't have domain knowledge of brain-computer interface. Or you can say, what is a brain? What is a cognitive neuroscience? What is a cognitive behavior of person? What is a frontal lobe? What is parietal lobe? In the brain, there are 4 lobes: frontal lobe, occipital lobe, parietal lobe, temporal lobe. Every lobe is responsible for something. When somebody is, what you can say, emotional, frontal lobe is responsible, I mean, more active. When language processing is being happen, I'm converting it. Whenever somebody is speaking English, see, try to understand. When you speak English, if English is your mother tongue, then your brain will convert your mother tongue. It is English, so by default, your brain will understand in English. But when your mother tongue is Telugu, when somebody is speaking in English, you will feel that you are understanding English. It is not true. Try to understand. It is the first language, your mother tongue. When somebody is speaking to you in English, your brain converts English to your mother tongue because that is the first language. When you say banana, you'll always remember as the word in your mother tongue. When somebody say banana, you will convert banana to the word in your mother tongue and you will imagine the appropriate figure. That's how the brain functions. Such a level of depth you have to understand in your domain knowledge. That's how domain knowledge. That's why I told. Now tell me, without domain knowledge, when somebody has only computer science and mathematics, tell me where you will hardly end up. Somebody answer.
Machine learning.
Yes, you will be a good machine learning person. Fine. So because you have good mathematics, you have good computer science, but you don't know how to. Now see, I know I'm very good at artificial intelligence application, but unfortunately I don't have no idea about human brain and all. I don't know. For example, you see parietal lobe. Parietal lobe is for spelling of words, responsible for spelling of words. See the middle line in the parietal lobe. It is responsible for spelling of words. When somebody is asking you to spelling the word, you are taking the data from. You want to see, somebody wants to see your spelling capability. Then that time you are recording from frontal lobe. That is wrong. You have to record from parietal lobe. But you are recording from frontal lobe because you are lacking knowledge in domain knowledge. You are lacking information of domain knowledge. Because that's why you can end up with a good machine learner, but not a good data science person. Because you don't have much knowledge in domain. No, you should also have domain knowledge. Okay. That's how. When if you go to a shop, maybe a bakery or maybe another confection shop, when somebody make a good cake, if it doesn't know how to slice it properly, how to decorate it properly, though he's making very nicely, nobody will buy it. The same time, if you have a good knowledge of mathematics and computer science, if you don't have a front-end application, you may not be able to sell your idea. Anybody has doubts? Somebody is speaking. Please turn up your microphone, all of you.
సర్క్యులర్ వచ్చింది కష్టం నీకు అదే పెట్టినా కదా సర్క్యులర్
All of you, please turn off your microphone. Somebody is speaking.
వాట్సాప్ లో పెట్టినా చూడు రిజిస్టర్.
Now, sensing the brain, we have various type of data: EEG, fMRI, NIRS, others. EEG already you know is the displaced electric signal that we have coming out of the communication of the neurons, millions of neurons. When millions of neurons communicate each other, then the electric signal will be. And a brain. What is the reaction happening? Is a chemical reaction. Chemical reaction result into electric signal. Try to understand. That is EEG signal. Similarly, we have fMRI. It detects the blood flow. There is a change in the blood flow. It used to identify and make some assumptions based on that. Similarly, NIRS and other type of. So we have now there are 2 ways to record the data. One is invasive, other one is non-invasive. Invasive method, we used to cut the scalp and skull bone and open the skull bone and connect the electrodes directly to the human brain. And other is non-invasive. Brain is located under 4 to 5 layers, that is scalp and periosteum, skull bone, dura mater, and so on. So under which brain is it? The brain should be carefully. We are collecting the data from by collecting the electrodes and the hairs or scalp. Okay, so this typical BC application for your real-time system. So this is how the processing happens. Now there is a neuromodulation application. Those who are interested in that biomedicinal application, bioinformatics and all, they can see this neuromodulation, where there is a spinal cord injury or something, where people can use some artificial implant with an electrode and a chip inside the brain, and the end of the electrode can be placed maybe via the close to the spinal cord. This is used to treat with Parkinson's disease and other epilepsy and other type of problems. Okay, and then there is some problems with this. Everywhere, see, Here we are not going to do any operation, any surgery. Please try to understand. You make the device, connect the electrodes and record the data. Okay. But mostly many of the computer science and other allied areas, they do research in non-invasive method because we are difficult to get the data by opening the skull bone and then connecting the electrodes directly to the human brain. We are taking the data from only by connecting the wires to the hairs or the scalp. Okay. So with some other application like there is something called magnetic pulse we are going to use to project on a particular region of the human brain, maybe frontal lobe or parietal lobe, whichever the lobe. For example, somebody is under depression. To make the depression get rid, we are going to use a magnetic impulse to be generated onto this one. And we are going to record the data every time. Then after recording, we're going to analyze whether his depression is get rid or not. Then there are some problems. Similarly, we are going to use some other IoT applications, some IoT application where the person has a missing limb. And simply you connect the data. If you see the figure, there are some electrodes are connected here. How the electrodes are connected and taking the data. Then the data you use for some training of the neural network and then take the decision. First you take some data, record for some trial. Trial 1, person 1, trial 1, person 2, trial 1, person 3, trial 1, person 4. And so 5% you take. Then each person trial 2, trial 2, trial 2, trial 2, and so on. So each person you have to go for some about some 10 to 20 trials. Take the data, train your network, and then use it for some decision making. Whether when the left leg is moving, how the right leg to move. We make some microprocessor, microcontroller, maybe Arduino or Raspberry Pi. Program it in such a way such that it will work according to how the left leg is working. Same way how it will work. Similarly, retinal implants, there is another application for your artificial intelligence. When the optic nerve is connected to the human brain directly, that carries the information of the images captured by the human eye, that is the cornea and the retina structure. When there is a problem with the visual communication to the human brain, you can make an artificial implant to be placed in the human eye or nearby. And it is connected to the optic nerve, and the optic nerve carries the information of the image that is captured to the artificial chip to the human brain, because human brain is directly connected to the optic nerve and to the eye. And this is such a type of data you can record and use it for some real-time processing, and whether the person can move or walk. There are some persons who have used these implants and placed in their body, and how the communication happens and how they have survived and to do the things normally. Okay. And it was developed in 1929 and still people have used it heavily. And then if you see, there is a figure, different type of signals we have seen. When the brain is alert, it generates beta waves. When brain is relaxing, alpha waves. When somebody is sleeping, we have theta waves. When somebody is light sleep, we have different waves. When somebody is deep sleep, we have delta wave. When somebody is paradoxical sleep, we have dreaming wave. Now, somebody tell me, for example, you are sleeping. When you are sleeping and next day when you woke up, when you wake up the other day, the next day, can anybody tell that you have had a dream? No, only you are the person can say whether you have had a dream or not. But if you can connect the electrode to the human brain before you go to sleep the other day, and next day I can say that if you have paradoxical sleep, then you have REM signals. When you have paradoxical sleep means dreaming. When you are dreaming, you will have paradoxical sleep. You will have the REM signals to be generated. Then if at all such a signals are generated, I am going to say that what? You have had sleep, and in sleep you have had a dream. But can you say whether the person who has had a dream, who had a dream, can he say that what time he has had a dream? Nobody can say what time you have had a dream. Everybody can say that, okay, I had a dream the other day night, but nobody can say what time. But we can say, if we can connect an electrode and what time the starting point of this REM signals generated, we are going to say that what? This time your dream was started and this time it is ended. You see the kind of application we can have. And each signal has a separate RAM, beta 13 to 30, alpha 8 to 30, theta 4 to 8, delta 0.5 to 4, and so on. So there are some applications how the people have used these type of behaviors, or you can say signals, by just interfacing their human brain and then connecting to some outside external device, a wearable device, and how the person was surviving 5 years. The entire setup using your artificial intelligence applications and the data acquisition system There is an amplifier connected to the human brain and the data is collected and the feature extraction, something happen using your artificial intelligence technique. And finally connecting to your device. Here device is, if you can see, it's a wheelchair, smart wheelchair. The person who is a locked in or immobile or paralyzed person who can't move or walk or speak, he can control, he can only see. So he can control the external device like wheelchair by just commands from the human brain. All such application we can have. And similarly, brain has many regions where people can focus upon working. And you have to select, like I said, domain knowledge. You have to know where you have to take the data from. Otherwise, you can't easily end up with a suitable label data that is for your training of the neural network or any other purpose. Okay. People can use it for some gaming application and other object control manipulation and other tracking applications and all. How people can move the cursor towards a target by just taking the data from the then there's a non-invasive BCI, how the people can connect the electrodes, connect the what you can easy cap to the human brain and take the signals. Then we have some other gaming application where people are using all these things. What shown in the figure is a simple EEG channels device, wearable device. That is single channel device where people taking data from single channel. What this is like a gaming application, like a distributed VR virtual reality system application where people are using for some real-time application like controlling the games. Now, the future of these BCA and all with the development of the artificial intelligence approaches, I've already mentioned what are the pros and cons of this particular case study and others. Okay, now I'm done. You have any doubts? Please let me know.
Thank you.
Yeah, thank you, sir. Now the session is open for queries. Participants, do you have anything to ask to convey to sir? You can. Any clarifications you want? Any queries from your side? You're welcome.
Thank you for accepting our invitation and giving the informative session on the particular context, sir. Damodar Reddy, sir, thank you for your acceptance. Sir, can I read the questions which are posted in the chat box? Sir?
Yes, sir. Yes. He is
Yeah,
asking. There is a question. There is a question why the person will respond if you are asking questions which reveals personal information like ATM PIN number. Yes, the person knows that we are asking questions to reveal the ATM PIN number. Why he will respond? Yes. Now, see, you should understand. When I ask your name, you don't want to tell your name. You will speak out your name wrongly. But brain never lies because that's the cognitive behavior. Because see, you lie outside, but you will never lie yourself. When you are talking to yourself, when somebody is asking so and so question, it will reveal that what your brain knows. Okay, out of some 10 questions, this is the correct signal. This is not the correct signal. So certainly that you will think that you will not really reveal, but the cognitive behavior will never be what you can say wrong to yourself. That is the reason how you make the technology. And I did not say that you will get with 100% accuracy. There could be other region. If the person is tensed and so on, so region, there could be some factors where you may end up with wrong conclusion. I say you can do when the technology gone to such a level of research. It is possible. At this time, it is not possible. But like you are telling, the person will never say that's wrong because the person will already he knows, unless he forgets the first digit, he knows that it is the first digit. So though he wants to lie, he can't lie himself. Yes. So now, any other doubt? Any other doubts? Please let me know.
Sir, there is a movie called Maya One in
Okay.
Telugu. Is it possible in which he changed the brain, store the our brain in a disk and replace our brain in a someone?
No, that is different issue. That was such a research is not at all going at this. See, now also we are going to brain computer interface only one direction. we are trying to connect some wire and taking some data. Okay, now when the brain computer interface has gone to such a level of research, on the other direction we can think like what we can connect a wire and store some information in the brain. But for now we are only thinking of one level of research, that we can connect some data from the human brain and then take some data from the human brain, some EEG signals. Other side of research is what, trying to send some data to the human brain. Okay, after that you are going that what you can say, that brain implantation and all those things are like you have heart implantation and all. That is not, that is the movie anything can happen. Any other doubts?
Yes, sir. Someone, Dipali is asking about, let us know what can we do in deep fake using artificial intelligence. Let us know what can we do in deep
Now
fake.
uh, can can they elaborate the question? Deep fake using AI means, for example, see, when you have such a deep fake network, you try to take data from multiple subjects and try to train your network model and see what type of cognitive behavior persons are acting according to what type of questions. And then you train a model according to person categorization. You can make such a type of research to be, such a type of data acquisition can happen. Then you can make some feature extraction. Then you can use some optimization algorithm along with this particular deep network and then try to use it for some real-time application.
Okay. So one more from Sweta Suresh. Since we cannot get easy data easily, is there any other method to detect emotions rather than face detection?
Emotion detection basically can happen from the data from the human brain, and even if it's not from face detection, it's not so easily possible. Basically, see it, emotional thinking. When somebody is emotional, it is not only face, whole body is responding. You can take his blood pressure, you can take his pulse rate, heart rate, skin conductance and all. That data is directly or indirectly connected to your emotions. But the main problem here is the person's, that the data that you are collecting, that is secondary level data. When somebody is emotion because of the human brain, the other organs are trying to impact. So here it may or may not be effective. The data that you're collecting may not be so significant, may not be very useful. It's like a secondary data you're taking. So better you take from the EEG signals or facial expressions.
Yeah, okay, sir. Thank you, sir. So far, I read what are the questions posted in the chat box. Participants are requested to clarify your queries if you have with the speaker. Meanwhile, thank you for accepting my invitation and giving your wonderful session
Thank you.
with the
Thank you.
real-time application, sir. Hope participants are benefited from your enlightened session.
Somebody was asking my email ID. I posted in the chat box.
Yeah,
So please,
yes, sir. Yeah.
note.
Thank you. Thank you.
Sir, one more question. In lie detector mission, AI is used or not?
Yes, yeah. See, when you're lie detection, I'm taking EEG data. I'm training my deep learning model. Like if so and so subject, so and so question, so and so data, if he's lying. Now, if for one subject data, I'm training, remaining 9 subjects, I'm testing on training on 1 to 2 persons, testing on 8 to 20 persons, something like that you can make. Train your neural network, deep learning, or genetic algorithm, or fuzzy, spiking neuron models, anything, or even you can use any other evolutionary computation model also. So you collect data from multiple sources of the persons or subjects, then design a model. First to train your, if it is a neural network, you train your neural network model. Any other doubts?
That's
Yes,
it,
sir.
sir. Thank you. Yeah. Thank you, sir. Thank you very much for sharing your insightful knowledge with us. Thank you. Thank you once again, sir.
Okay.
Yeah.
Any
So
other doubts
that's
also
all.
you can ask anybody, any other general queries, paper publication, SCI, Scopus, whatever, any other doubts also you can ask. We have another 2 minutes.
Okay, sir. Yeah, participants are requested to clarify our doubts, including publications So how to proceed to publish in a highly indexed journal or any proceedings? The speaker is ready to take your queries on publications. How to proceed with the research work to be published.
Sir, good afternoon, sir.
Please tell.
Sir, this is Venkateswara from KL University.
Ah.
Sir, actually, based on why I'm asking this question is, our doubt is, we have published so many papers every year, 2 or 3 papers we have published in the Scopus.
Okay.
But after a couple of days, maybe after 3 months or 6 months, that will be removed from the, that journal will be removed from the Scopus.
Yes, yes.
The doubt is there any common factors or very important factors which we can justify that this particular journal should be good in the sense it will never will be removed?
So
based
typically,
on based on what parameters we can justify that? Why? Because I have asked to so many professors also, but I didn't get any answer from anyone. Perfect answer. Is there any perfect parameters are there to justify this journal should be good? If we can publish our paper in this journal, it will be available some long period of time.
Yes, sir. Now your objective is Scopus or SCI?
SCI, sir.
SCI.
Web of Science. Intentionally, Web of Science.
Yes, SCI index. Now, sir, please listen carefully. Now, all of you, when whoever focus on Scopus, you try to keep your target as SCI, first of all. Whoever keep the target as SCI, at least. All of you try to understand there are a number of SCI journals. First, you exclude all, you may exclude all paid journals. Somebody can say there is no submission charges, but there is publication charges. There's article processing charges won't be there, but publication charges. Anything is paid only. Anything single rupee you are paying other than extra page length charges. Anything you are paying that is considered as a paid journal. Some people will say it's a paid. It's not a paid journal. There is no fee for submission, but after submission, publication charges are there. Anything is paying only. After excluding paid journal, open access. Somebody says okay, somebody says don't okay. But open access also you try to give your second option. Don't give to first option for open access. Okay. Sometimes open access also people may not like. Now other type of category remaining. Now after filtering the remaining journals. There are various database. There are if SCI database there are two main database. You go to SCI Mago. Type in the Google SCI Mago. There is a database gets opened. They type the journal name. When you type the journal name in SCI Mago, the journal name will be appeared. Then click the name. The entire history of the journal will come almost from the starting to till date, or till date in the sense till last year usually it will come. If it is 2020, at least till 2019 it will come, and it will tell the history of the papers. What type of papers are accepted here? The quality Q1, Q2, Q3, Q4. That is known as Q1, Q2, Q3, Q4. Try to send to Q1 quality journals. Q1 quality is a top journal. Good quality. If not Q1, you feel that your paper may not be very good, then go to Q2. Otherwise Q3. Lastly, you go to Q4. That is in SCI Mago. Okay? Many of the journals which are in Q1 quality in SCI Mago, they are almost Q1 quality everywhere, but some journals, they are in Q1 quality, Q1 quality SCI journals in SCI Mago, they may be Q2 or Q3 in that claritative analytics of Web of Science. If you want Q1 quality in Web of Science also, you go to Web of Science, the claritative analysis, there is something called, okay, claritative analysis. You go there and then type in the Google, the claritative analysis, then just type there the journal name, check whether it is Q1 or not. If there it is Q1, that is even more tough journal. Okay. So whether it is SCI Mago or claritative analysis, you go for Q1 quality journals first. If not Q1, then go to Q2, then Q3, and so on, so on, so on. Okay. That is one way of finding the quality of the journal. Okay. But above all, some of the IEEE transactions also may not be SCI index journals. Okay. So don't keep in your mind that Scopus or SCI is the ultimate target. Some of the top journals may not be SCI index journals. You need not worry. But sometimes when it is comes to IEEE journals like IEEE transactions, don't bother whether it's Scopus or SCI. There's always brand, right? Now considering the selection, like answer to your question, you go to the journal database, check Q1 quality journal. I'm sure it will be, maybe 99.99, it will be in SCI and Scopus, if it is a Q1 quality.
Okay. Sir, as you told, for SCI, we have the feasibility to check if it is there in Q1 list, then we can proceed blindly like that.
Yes, every SCI journal, when you go to Web of Science or Clarivate Analytics, there is a search option. You type with the journal name, you will find whether it is Q1 or Q2 or Q3 or Q4. Okay, na? But
Thank you, sir.
compared to SCI Mago, Q1 in Web of Science Clarivate Analytics is even more tough. Okay, even SCI Mago Q1 also very good journal only.
Okay, thank
Hello,
you.
sir.
Yeah, sir, one of the participant is asking you to suggest some novel research topics, ideas to pursue for publication regarding AI applications in tourism and hospitality.
Tourism and hospitality, you can make some prediction models like so and so time when the tourist visit, this is the best place, this is the best hotel, affordable price, like a package prediction. Like somebody wants to go to Goa, so in Goa one can make a package prediction, like this is the hotel, these are the places to visit, and so on. So this is the best time, and this is the complete package. It will try to generate such a, but problem is there are actually type of tools or what you can say program related research. Getting them published would be difficult. Normal transportation and all okay, tourism related and all, when you go for it is mere of programming or tools type research. When you are making, getting them published is not so easy. You can make a suggestive models for tourists for optimistic experience of the place they are going to visit, whether it is suggesting hotels, suggesting purchase of some goods there, some shopping or any other something like, but it could be a kind of application rather a research. Any other questions?
Yes, sir, thank you. And one more question. Why artificial intelligence is not used in cricket to classify the sound, whether ball hit the pad or bat?
With that hacker technology, how they are using, that is artificial intelligence only. How hacker used, how the image is being captured. When the 3D visual image is created based on the hacker technology, they are using completely image processing and artificial intelligence. That's artificial intelligence. When the visual 3D image is created, how the ball was touching the pads are bad, and it is also predicting, because the ball can hardly touch the pads. After that, based on the considering speed and dimension and the height, it is going to predict it is going to hit the stumps or not and the bails or not. Then it is a kind of prediction they are making. So that is artificial intelligence only. Without artificial intelligence, there is no hacker technology, I believe.
So my question is that when ball hit the pad close to the bat, then umpire does not decide that okay, ball hit the pad or bat.
Yes.
When it is close to pad or bat.
See, but problem is you are making real-time analysis. It's not a real-time analysis. You are processing, and the ball comes with what you can say 100 miles per hour. Maybe you can say, Arjun, with a lot of high speed. In that case, you are making in fraction of second to be processed. Whether it's not so easy. And I've already told some problems even with the retinal implants that artificial limb, that IoT application I have shown. The main problem with is what, when you are walking with artificial limb, your processing with real time is very difficult. Those who are using artificial limb, they have to walk very slowly because the real time processing is not so easy. Now you can imagine the ball that comes with 100 miles of speed, getting them real time processed and telling them with a minor noise is not so easy. We are using artificial intelligence already at maximum level in the hacker technology and other techniques in cricket. But such a level of accuracy may be achieved in future. See, Hakai was not there some 1 or 2 decades before, 2 decades before. Now it is there. Maybe after 5-10 years it will come. When such a level of high-speed model comes, then it might come. Next question, please. Any
Yeah,
other?
thank you, sir. Yeah. Sir, can you suggest a proper roadmap to practically strong in machine learning and deep learning domain?
Now you start with the conventional. First of all, take up the course of soft computing. First, all of you who are in need, take up the course of soft computing for at least 3 times. All those who want to do very good at these data science related areas, first you do take up soft computing course for 3 times. Course
Where,
in the sense
sir?
not take just read for 1 or 2 weeks and tell that it's over. No, take a full semester course for 3 times. Then you slowly, you need not to be very good at each and every topic of machine learning and all. Many of the research areas can be solved using the soft computing applications. So maybe you can create a center for soft computing at your areas, at your colleges, and take up the course, continuously offer this course for 3 consecutive semesters and learn yourself. Then, or teach yourself if you are a faculty. Then you will be very good at the subjects.
Sir, my question is practically, how can we strong? Because I want to implement the things. So theoretically, I am okay. I know the concepts. But if I want to implement the things here, real-time data, using the different data sets, like for example, image data, health sector, I want to work. How I can proficient in this particular domain? How I can get the confidence?
Yes. Now see, when you say the amount is you practical implement. Now,
Yes.
if you have a BTech or PG student, you assign each student a particular topic, different topic. One you give deep learning, one you give extreme learning machine, one you give genetic algorithm, one you give rough set theory, one you give type 2 fuzzy logic, one you give other evaluation models. Then give them each different applications. Each one, because already you know the topics. Now you give them different applications. Fine. Each student, if you have at least 1 or 2 UG student and 1 or 2 PG student, 4 to 5 student, give each one a different topic. Then you take. Otherwise, if you have no student, you take data of 4 to 5 different types. Just take lung cancer data, lung nodule data, then CT scan data, ultrasound data, then type 2 diabetes data. Many of the data sets are available in the UCA repository. Some of them maybe you have to collect some from hospital somewhere. Then each one you run on something, because you said already you know the theoretical concept. One you run on ELM, one you run on deep learning, one you run on genetic algorithm, one rough set theory, one type 2 fuzzy logic, one using Sugudani, one using Mamdani model, something like that. Then you see what is the accuracy. Then compare with the existing benchmark models. Try to improve the accuracy. That's all.
Thank you, sir. And one more. How UGC scare journals different from Scopus indexed journal?
Madam, can you stop the recording?
Yeah, sir. Yeah.
I want to answer this.
Sir, you can, sir. Yes, stop, sir.
Madam, I don't say it's good or bad, UGC care journal, but problem is there is a plenty of journals I have seen. Many journals are there in the list. Hence, it would be difficult to classify which one is really good, which one is not. And I don't want to comment that something is a bad journal or not. But what I suggest, you don't go to, I don't say really if some top rate journal you say and select and publish and UGC will never agree. Definitely, for example, when you are targeting some IEEE transaction, some ACM transaction, some good Elsevier or Springer or Wheeler or Taylor Francis journal, then whether it is UGC care or not, you don't care it. You don't care whether it is in UGC care or not. For your career purpose, for your PhD, if some journal is there, in KGC, UGC care list, you select the journal, check it is in a Scopus index or not, and publish that, and it's over. Next, you don't publish if you feel that it is not a good journal, but that is in the UGC care list. I don't mind to say that. You target some top journal, like, see, first you always there is like a hierarchy. You target this top journal in like ACM transactions, ICM, IEEE transactions, IET, and others. Okay. If not them, we come back to at least normal IEEE journals. May not be transactions. Then not IEEE, then ACR, then normal ACM. Okay. So either transactions IEEE ACM or normal IEEE ACM or elsewhere, then Springer, Taylor and Francis, Wheelie, all those things. If not any of them, then you go to any normal SCI journal. Then you come back to this UGC care list journal. Okay, because I'm telling you, I have seen hundreds and thousands of journals are there to such a list. I can understand because there are various type of domains and researchers are there. But question is, you can publish 1 or 2 journals from the UGC care list, serve the purpose of your PhD. Once it is done, you target patents, and then why I'm telling this, there is a reason. Whether this UGC care list was there in the some 5 to 10 years before, maybe a decade before it was not there. Now they are telling UGC care list. Now when you publish UGC care list, after some 10 years, they might say, I want only SCI journal. Now this is Scopus journal, not SCI. By that time, it may not be useful to you. If there is a new rule comes all of a sudden, I want only some SCI journal, some IEEE journal, or at least one transaction, and at least one what you can say patent also might be there, because whenever I was doing PhD, SCI was not mandatory. Nowadays, everywhere SCI at least Scopus is mandatory. After some 5 to 10 years, it becomes mandatory. There may be a SCI journal or IEEE transaction or even a patent also. So we are in a world of competition. So better you target heavy and go for such a level. I do not say don't go for UGC care list. You can go for, but in a limited way up to your career requirement. Once you have your PhD thesis submitted, you target high journals. Okay. Don't mind whether it is in the UGC care or not.
Yeah, thank you so much, sir. Sir, this is the last question. So somebody are asking you to suggest some problem statements on disease prediction.
Disease prediction. Now what you can do, you can collect the MRI data, take the MRI data, and then go for maybe MRI data or CT scan data, any data. Some just you can take some conventional neural network, CNN with some features also. Just make an early prediction of the diseases, early prediction of a tumor or something. This will help you for what whenever such a type of prediction you are making. See, one is detection of the brain tumor or maybe other tumors. Next is early prediction. Prediction and early prediction. Early prediction can give you easy treatment to that particular disease. So you can take, but for that you require some label data. The patient data who was predicted with tumor and the same patient MRI data who was before it was predicted or before it was detected. So you can take some features in the first image where there was no tumor predict, and then you can see the image where there is a tumor prediction. How it can be happen when somebody was not symptomatic and there are some symptoms seen, the tumor is going to appear, something like that. Then the tumor is appeared. So such a kind of data, when varied data you collect, you can see some data to be taken, and then you can predict the tumors early. So you can, if it is not predicted, at least you can say that benign or malignant tumor in the early stage. All such medical application you can take when you take the data from. That is in medical imaging, a lot of research is going on. You take the data, use some conventional or deep learning models and run out some data. Or use some genetic algorithm optimization and use some data, something like that. There are a number of applications, and you can see any of my papers, and if you have any doubts, you can mail me. I will clarify further. I have shared my email and phone number in the chat box.
Good afternoon, sir.
Okay.
Good afternoon, sir. One question,
please
sir.
Please tell me.
Can I ask, sir?
Sir,
sir, I am working with the EEG data set, sir, for sleep disease detection. But sir, I have faced some difficulty related to assessing that annotation files of one particular PhysioNet data. That PhysioNet data set is there, where that recordings are in the EDF format. I have read that data, but some .hyp extension files are not able to read it.
Yes, so, actually, the problem is that such a type of data acquisition system records the data in their own format, customized format. Then you have to have their own. That is actually kind of business they make. For example, here where we record the data, then there is something. There are two softwares they are giving. One is for data recorder, one is for data analyzer. So after recording the data, we have to convert to some .m format, like you can use in your MATLAB. So to your question is, after recording the data you're taking, they have recorded in their own format, and then they have not converted to datum format. For that, you require their recorder software. Otherwise, you can't easily use their data. This is all like proprietary business, like commercialization. So what my suggestion is, you go to some institution like NIT Goa, there is a data acquisition lab, you record the data of your interest, whatever you want to record, why use somebody's data, then convert to your format, .m format, and use in your MATLAB.
Okay, sir. In NIT Goa, is the data EEG data is there, sir?
Yes, 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 yes. We have a data acquisition center. We have separate lab.
Oh, okay, sir. Sir, can we go for mail?
Okay, sir. Yeah.
Can we go request mail? After request mail, can we they allow for us to access that facility, sir?
You send a mail to me, sir. I will see.
Okay. Thank you so much.
You said that is my lab only. That is my lab only.
Okay.
So you send a request to me. I will see. Okay.
Okay, sir.
Yeah. Thank you, sir. Thank you so much for clarifying all the queries with patience beyond the time also. Thank you very much, sir.
Sure, madam. Right. Thank you. Thanks for inviting me. And I'd like to thank the college and the head of the department and all the faculty members who are inviting me. I would also like to thank my friend who is there working, Mr. Pawan Kumar, who was my colleague here at NIT Goa when he was working. And I'd like to thank each one of you. Thank you very much. And at any point of time, any doubts, you can mail me. I'll be happy to clarify. Thank you. Signing off.
Thank you,
Yeah,
sir.
sir. Your session was informative and valuable of knowledge, sir. Thank you. Thank you so much, sir. Yeah, dear participants, now we'll break for lunch. So afternoon session, it will start at 2 o'clock, and afternoon we have valedictory ceremony. So it will be from 2 to 2:30, and from 2:30 to 3:30, you'll have online assessment exam. So we are going to forward the link for online assessment exam through Google Forms only. So exam will start at 2:30. So afternoon valedictory ceremony from 2 to 2:30, and 2:30 to 3:30 we'll have exam, online assessment exam. Thank you. Good afternoon to all the participants. We'll start the valedictory ceremony in few more minutes. So meanwhile, I'm just forwarding you the overall feedback form link. I request all the participants to fill that form. I request all the participants to give the feedback about this short-term training program. We have shared the form link in the chat window. After valedictory ceremony, we are going to post a link for online assessment exam. This exam contains 20 MCQ questions. So to issue e-certificate, you should have to attain minimum 60% of the score. So after this event, we are going to share the link for online assessment exam. Thank you. Welcome back. Good afternoon, all of you. A very warm welcome from Department of Information Technology, VNR Vignana Jyoti, Hyderabad. I welcome you all for this valedictory function. The end of a story is the new beginning for many others. On this note, let us conclude a remarkable, memorable, and knowledgeable event, valedictory section of this short-term training program on machine learning and deep learning techniques for artificial intelligence problems using Python. We welcome our principal, Dr. C.D. Naidu Garu, and Dr. B. Chennakeshwar Sir, Director for Advancement, Dean Administration, and Dr. G. Suresh Reddy Garu, Head of the Department, IT, VNR VJIT, and Dr. D. Srinivas Rao Garu, Coordinator, STTP. Good afternoon, sir. I would like to request coordinator of this STTP, Dr. D. Srinivas Rao Garu, to give summary about this STTP. Over to you, sir. Srinivas Rao, sir.
Yeah, thank you, ma'am. This is a great privilege to share my summary report on online 6 days AICT sponsored short-term training program titled Machine Learning and Deep Learning Techniques for Artificial Intelligence Problems using Python, Mldlt 2020, scheduled November 16th to November 21st. We have started the STTP program with the inaugural session by introducing the retired professor Dr. SSVN Sharma as chief guest and delivered the scope of the program that gives the insights of machine learning or deep learning in computer science domain, followed by the fundamentals are discussed by the speaker Dr. M. Sita, professor and head G. Narayanama Institute of Technology and Science, delivered fundamental blocks of machine learning and deep learning as well, followed by the afternoon session delivered by the Dr. SSVN Sharma on the essentials of mathematics for machine learning techniques. These are about the sessions handled on first day. On second day, 17/11/2020, Dr. D. Srinivas Rao delivered features of Python libraries to be required to develop machine learning and deep learning applications with the help of Collab, and discussed about various integrated development environments like Spider, TensorFlow, PyTorch, etc. For the second session of the forenoon, Dr. S. Somarazu from NIT Partner delivered the session, a practical session on data preprocessing techniques, which is the primary and initial step to be implemented before going to be develop and test the any machine learning technique. In the afternoon, there is a session titled Data Modeling and Visualization using Python, delivered by the Dr. M.H.M. Krishna Prasad, Vice Principal, Professor of JNTU Kakinada. On third day is on 18/11/2020, Dr. D. Ramesh from IIT Dhanbad delivered a session on regression techniques respect to the simple linear and multiple linear approaches with reference to the machine learning context, followed by the second session on forenoon, the titled Logistic Regression and Applications with respect to the computer science domain by the speaker name Dr. Kavati Ailaya from NIT Wangal. In the afternoon session, there is a session titled Neural Networks for Image Classification by Dr. Sanjeev Kumar, Associate Professor from IIT Roorkee. Delivered the elements of neural networks with the inception of perceptron and delivered the insights of neural networks for image classification. On the fourth day, that is on 19th level, the session titled Decision Tree Classification and Adversarial Machine Learning by Dr. P. Rajendra from IIT Dhanbad. Delivered the session with the help of decision tree classification by taking the dataset example related to income tax payment and refunds to be given on the basis of machine learning approaches. Followed by Dr. G. Madhu delivered the session on deep learning and convolution neural networks by giving the demo on the perspective of processing the image with the help of convolution neural network and also introduced Lennet of deep learning approach to do the same. And in the afternoon session, there is a topic titled and scheduled Ensemble Learning is the process of combining two or more models in parallel to improve the performance of the machine learning with the advanced technique delivered by Dr. C.H. Ramalingaswamy from NIT Warangal. On the fifth day, that is on 20th 11/2020, Dr. Ramakant Mohanty from Geetanjali College of Engineering and Technology delivered the session on K-means clustering and hierarchical clustering and also introduced the K-name tool for the implementation of clustering approaches. Followed by the industrial person from TCS named Dr. M. Ramesh, working as IT analyst. He delivered session on density and grid-based clustering techniques used for clustering the elements having the similarities with respect to the real-time applications. Followed by panel discussion, which is scheduled in the afternoon session to share the views, to clarify the doubts of participants. We have allowed the industry people to share their views with respect to the industry, what's happening and what are the domains on which faculty as well as students to be focused so that the students will be ready for the a good placement. We have invited Dr. P.V. Ravikumar, he the chief architect from Ericsson, and K. Lakshman Srikanth, Legato Health Systems, he the team lead, are invited from external sources. Apart from them, Dr. G. Madhu and Dr. D. Srinivasrao and other participants shared their views on the given context. On the special request received from the participants, we also added additional session to conduct the importance of image transformation with respect to the implementing machine learning and deep learning approaches for the image transformation where the mathematic foundations are required. That is the reason we arranged the additional session with the help of the speaker, Dr. S.S.P.N. Sharma Garu, a retired professor, Kakatiya University, Warangal. Basically, he's from mathematics department and did PhD in computer science and served as a professor in the computer science as well. He's suitable person to deliver machine learning with the help of mathematics as having the knowledge in both the sectors. And on today, that is Saturday, last day of the short-term training program, 21/11/2020, we have started the session titled KNN and SVM techniques used for classification. At the session delivered by Dr. N.C. Naveen Kumar from JSS Academy of Technical Education, Bangalore, delivered the session with the help of the Python libraries used and delivered the real-time examples where KNN, SVM, and also given the insights of RVM and IVM, which are the most advanced techniques, relevance vector machines, is the area where we have the scope to continue the research, or the additional topic given by Dr. N.C. Naveen sir, followed by the session titled Applications of Artificial Intelligence with respect to the scope of artificial intelligence problems in the real time, and also delivered the very important and common topic required for all the academicians, titled the procedure or the roadmap to publish the paper in the highly indexed journals. This is the talk given by Dr. E. Damodar Reddy sir from NIT Goa. With the much patience, he gave the precise responses to the queries, lot of queries raised by the participants from both the platforms of Google Meet as well as YouTube stream. With these sessions, we have concluded the 6-day online AICT sponsored short-term training program titled Machine Learning and Deep Learning Techniques for Artificial Intelligence Problems Using Python. In short, MLDLT 2020 Series 1 and Series 2 on Deep Learning Techniques will be conducted in the third week of December 2020. This is the summary of the HTTP program conducted. On behalf of coordinator for this HTTP session, I should thankful to AICTE for giving opportunity to conduct this particular HTTP through online session, and I should thankful to Principal Dr. C.D. Naidu sir, Director B. Chennakeswara Garu, Advancement and Director for R&D Subhanandrao sir for supporting me and monitoring us and guiding in a precise way in the advanced with the long vision to learn and to disseminate the knowledge to the students well in advance compared to other co-organizations. And I should thankful to our beloved HOD Dr. G. Suresh Reddy Garu to constant support and guiding us in a precise manner to do the things in a right manner. The last but not least, our co-faculty and co-coordinator for the STTP, A. Revati ma'am, to arrange all the things in a proper pipeline and executed within the stipulated time. Though we have faced big problems because of some bandwidths or some overlapping of the timings of esteemed administrative people, little bit delay is done. Sorry for that inconvenience. And finally, I should thankful to all the participants from various organizations registered, collected from 23 states, and also we have participants from Bangladesh as well as from Malaysia who proudly say to that our participants are actually involved, and I hope that you received the proper inputs and informative content from all our speakers in this particular HTTP session. And I recognize that you are actually participated as you are asking the queries on various concepts to the speaker at every particular context in the each and every session. Interprets, you are participated and received the proper information to you to continue your profession in a successful manner. Thank you one and all for all the support given, either directly or indirectly, the colleagues of VNR VJIT and other esteemed faculty from other organizations for your wonderful support to do the event in a successful manner. Thank you one and all.
Thank you, sir. Thank you so much for your giving summary about this STTP. I consider it a great honor to welcome Dr. A. Subhanandrao Garu, Director R&D VNR VJIT. Good afternoon, sir. We welcome you to this valedictory session, sir.
Good afternoon.
Yes, sir. Yeah. We would like to request respected Head of the Department, Information Technology, VNR VJIT, Dr. G. Suresh Reddy Garu, to share his views about this STTP. Over to you, sir. Suresh Reddy, sir.
Hello, good afternoon, everybody. Hello.
Sir, yes, sir. We welcome
Are you
you,
able
sir.
to hear me? Okay.
Yes, sir.
Just
Yes,
tell,
sir.
that's what I have.
We welcome our principal, Dr. C.D. Naidu Garu, VNR VJIT, to address the gathering with his words. Naidu, sir, we welcome you, sir. Yeah.
Yeah. Hello.
Sir, we
Good,
request
good,
you.
good afternoon, everybody.
Good afternoon, sir.
Good afternoon, everybody. That's a concluding session, it looks to be, on machine learning, deep learning knowledge have been incorporated into the minds of faculty. So we thank the AICTE and for funding this program to conduct in two series, Series 1 and Series 2, for funding from AICTE. And I congratulate the Department of IT for organizing this STTP program on advanced technologies, so that the faculty are benefited through this program. I hope I have a good learning for this week time for this program from the faculty. I thank HOD and of IT and the organizers of this STTP for conducting this program. Thank you very much for giving me this opportunity.
Thank you.
Thank you, sir. Thank you so much for your sharing, sir. Thank you. Now,
Thank you, sir.
yeah, I would like to request Director for Advancement, Dean Administration, Dr. B. Chennakeshwar, sir, to share his views. Over to you, sir.
Yeah, thank you, Revati, for
Yes.
inviting me. First of all, I would like to congratulate the Department of IT for organizing this one-week STTP program on machine learning and deep learning techniques for artificial intelligence problems using Python Series 1. In this connection, I would like to express my heartfelt gratitude to all the experts who have come forward to deliver the lectures during this particular 1 week on AI and machine learning, deep learning techniques. I think equally it is important for delegates also, because without delegates, I think it is very, very difficult to conduct any event successfully. Okay, in that way, I think I would like to express my heartfelt gratitude to all the delegates. I think you have come forward to attend this 1 week faculty development program at VNR VJT virtually, because it is not possible to connect physically. Okay, so respected Suresh Reddy Garu, Head Department of IT, and respected C.D. Naidu Garu, Principal, VNR VJT, and Subhanandra sir, and all other my colleagues and ladies and gentlemen. In this connection, actually, so whatever the I think knowledge that you have gained during this last 1 week, so please try to share with your fellow colleagues and friends, so that definitely we can disseminate knowledge, because nowadays everybody is talking about only machine learning and deep learning only. There is a great demand for these courses. So that way, I think you have an edge over other faculty who have not attended this program. So in this connection, I would like to thank A. Srinivas Rao, D. Srinivas Rao Garu and Revati Madam. I think you have done extremely good job. I would like to compliment and as well as congratulate both of you for successfully conducting this 1 week STTP program. But what is the outcome? That is also equally important. At the end of the day, definitely, I think you might have enriched some knowledge in this particular field. I think some of the people, those who are pursuing especially research, that is a PhD program, definitely they'll have an edge. And those who are going to take up research in this particular area, please try to learn, because this 1 week is not sufficient to learn all the techniques. Okay, only few things I think our faculty and outside experts also might have discussed in this particular platform. So please try to continuously use, especially this Python is very, very important nowadays. I think everybody is talking only Python. So please try to learn as much as possible and try to implement in your daily life in this particular area. But as research is concerned, AI, machine learning, I think everybody is apply that the use cases already, some of the use cases are already available. So please try to use all those use cases and try to acquire some knowledge in this particular area and try to implement in your PhD problem. So that way, I think this type of I think learning definitely will help you to get more knowledge. And if somebody is struck off in their PhD problems, definitely you can discuss with your fellow friends and try to implement all these tools that are available readily. And that way, I think you can complete your PhD as early as possible. And those who are doing some research projects, definitely I think you can implement all these tools. I think especially we have 10 PhD students. Out of 10 PhD students, nearly 4 or 5 people are doing research in this particular area, machine learning and deep learning only. But as for the knowledge is concerned, I think knowledge is like an ocean, okay? And definitely you need to go through some standard textbooks, especially that is missing actually nowadays, because everybody is referring some material that is available on the web, but that is not at all good actually. Please try to go through some standard textbooks and or some standard journals, so that definitely you can get some solutions out of all those problems that are facing today. But as for the application point of view is concerned, I think especially the agriculture sector, I think DC University is doing extremely good job. And he is implementing all these tools in agriculture sector, and even the Madhu also is implementing, Madhu and Mangatara madam in the Department of IT. They are also implementing in healthcare also. I think this is another important sector, healthcare, and then the second one is the agriculture sector, and third one is the transport. I think especially nowadays, I think it is very, very difficult to handle the vehicle movement on the roads. I think that way, I think these techniques we can use for all those problems, but the problems are plenty. That how you are going to make use of all these tools. I think Subhanandra Garu used to discuss about all these things. Which one is better? Machine learning is better or deep learning is better? So that way, I think both are, I think, very effective tools. And we also going to have some separate club on this particular area. Already we have started. I think Dr. N. Sandhya madam, I think she is looking after this club. And definitely, I think you should have whatever that experience that you have gained. I think you have to share and disseminate this knowledge to all other fellow friends. That is our main objective. And use cases also. I think already we have started some of the use cases here. So please try to make use of all these use cases and try to implement in your day-to-day problem solving. Okay. I wish you all good luck. Thank you once again, Suresh Reddy Garu and Srinivas Rao, and all other people, whoever is involved in conducting this HTTP program successfully. Thank you. All the best.
Yeah, sir. Thank you, sir. Thank you, Chennakeshwar sir. Thank you, sir, for your influential message, and we are charmed by your words, sir. Thank you once again. Now, it will be my honor to invite Dr. A. Subhanandrav Garu, Director, R&D, VNR VJIT, for his thinker words. Over to you, sir. Sir, please. Subhanandrav, sir.
Good afternoon, everybody. First of all, Naidu Garu, Chennakeshwara Garu, and Suresh Reddy Garu, Head of the Department, and coordinators, Srinivas Rao and Revati, faculty and participants. It is just half an hour back, Srinivas Rao told me that there is a valedictory session. Why don't you participate? Just before.
Thank you, sir, for your participation.
So immediately I had a lunch and ready at 2 o'clock here. Yeah. Then this year we are celebrating the Silver Jubilee. You must knowing, everybody knows that VNR VJIT is celebrating a Silver Jubilee year after 25 years of existence. And this is the right time. Many short-term courses, seminars, and FDP programs are being conducted this year, webinars. And this is one of them, and very, very important topic. This is machine learning and deep learning techniques for artificial intelligence problems. And this is the main buzzword, artificial intelligence is the main buzzword nowadays. And last 1 week, whoever is participating, it must be ringing in your mind, in your dreams, MLDL. I am sure that it is happening. Now, this year, many engineering colleges started a exclusive course in artificial intelligence dealing with machine learning and deep learning. You must have seen. And we also, in our core computer science, also have a track of artificial intelligence where students can take the related subjects and become their expertise, have their expertise in this particular branch of AI, that is ML and ML. 4 years back, I remember in our boardroom, we were sitting, our president, Dr. D.N. Rao, he was asked a question, I don't know if anybody remembers, what is the difference between machine learning and deep learning? It is 4 years back or 4.5 years back. Then we were not able to answer, even experts also were not able to answer because deep learning is coming last 5-6 years when it is coming. Then we looked at it, we just seen that machine learning is probably a subset of deep learning. What is machine learning? It's an algorithm that examines the data, extract its features, learn from the data, and make informed decisions based on what it has learned. This is the essence, what is the meaning of machine learning. So what is deep learning? Deep learning, as I said, is a subset of machine learning which uses multiple layers and it extracts the information progressively as it goes from lower level to higher level, extract the features from the raw input given and predicts. This is what essentially the deep learning. Why it is called deep? See, it is the neural networks is not new. It has been people are working from long years, and this ANN, because of a computational problem, people are working on 2 layers only. From last 2 decades back, it was only 2 layers. Now it is very common to build an algorithm using 10 plus layers. Many people are using 10 plus layers. It is very common, and even people are trying to use 100 plus layers in ANN. This is happening now. It is that people are trying to use 100 plus layers. So whatever the raw data or whatever is the data given, unstructured data, the deep learning by so many layers, it is able to extract the features, extract the information, and predict what is the information that is required. So this is the beauty of the deep learning, why the deep has come for learning. And it is growing exponentially. This, if you all over the world, global, it is growing exponentially. And this in 2022, they expect a business of $9 billion. 2022, and in 2030, in US itself, it is going to be $13 trillion. 2022, $9 billion. 2024, $23 billion. This year, from 24 to 2030, they are expecting $13 trillion of business in ML and DL in US alone. Of course, US is the major player. So that is going to be the importance of this artificial intelligence, machine learning, and deep learning. And it has got tremendous applications, number of fields. One is the autonomous vehicles. That is the main autonomous vehicles. It is a detection, classification, identification of vehicles. This deep learning and machine learning play a major role in computer vision. Healthcare. Healthcare is a very important sector, and most of our faculty are working in healthcare. Healthcare in malaria, typhoid, identification of vascular diseases, kidney diseases, and even from fundoscope, find out what is the position, what is the health of the heart. So a lot of work is going on in healthcare. And agriculture, as Dr. Channageswara told, that Srinivasa Rao is working to great extent in agriculture, how to use this deep learning in agriculture. Cyber security is the one which is one of the disrupting technologies along with AI. And AI got a number of applications in cyber security, transport, as he said, and semantic analysis, natural language processing, customer relationship management. This is one area, upcoming area, customer relationship management, banks, the stock prediction, financial management, business and decision making, and market forecast, whatnot. Every field, you mention a field, this application has got, this AI application. Especially nowadays in COVID-19, there are number of solutions that have come up in different countries, especially in biometric solutions. Identify the people having COVID, isolating them, warning them, and so many biometric solutions have been obtained in this COVID-19 period. A lot of development has taken place, and AI was taken extensively to the advantage of fighting with this COVID internationally. So that is what is important, exponential growth and number of applications. And I am sure you must have learned all these things in the last 1 week. I can see the experts from Srinivasarau's talk, number of experts given the talk, right, both from industry and academia as well. And we have taken the advantage of this pandemic. Otherwise, it is impossible to get all those experts at one platform because of constraints of the maintenance and constraints of their time. Everybody will not be available. They have to spend 2-3 days to come over here and give a talk. Now, thanks to this, and everybody virtually on virtual platform, they could give the talks, and you also have actually learned everything, many things you have learned in the last 1 week. I hope we will have a good takeaway to take home and work further based on this knowledge, improve your knowledge, conduct the research, and progress in this direction of artificial intelligence, which is coming up area, and it is very, very important area, and maximum importance in all the disruptive or mezzanine technologies. I could see that. So thank you very much for giving this opportunity, and wish that all of you go happy home with all this knowledge that you have got in this 1 week. Thank you very much. Thanks for giving me the opportunity.
Thank you, sir. Yeah. Thank you, sir. Thank you, Subhanandrao, sir, for sharing thinker words in this field, machine learning and deep learning. Once again, we thank you very much for your influential message. Now, I would like to request our HOD, Information Technology, Vienna VJIT, Dr. G. Suresh Reddy Garu, to share his views about this STTP. Over to you, sir, please.
Thank you, Revati. Yeah, at the outset, I congratulate all the participants who have been involved from last 1 week and learning all the important topic of AI and machine learning. First of all, I would like to thank AICTE for sponsoring this online short-term training program for a week. It's like a series 1, series 2, 2 weeks sponsorship on machine learning and deep learning techniques for artificial intelligence problems using Python. So I thank all the speakers, as rightly said by Subhanandrao Garu. It's very difficult to get these kind of expert speakers from IITs, NITs, from JNT University, and from industry prospects. So it's very difficult, but Dr. D. Srinivasarao and my co-coordinator Revati has done a wonderful job searching for a good people for this knowledgeable sharing, which is hot domain nowadays, the machine learning and deep learning. So I hope that the week deliberations have went on well and I have acquired enough knowledge in series 1. Similarly, in series 2, which we are going to host from December 14th through 19th, particularly on the deep learning techniques. So definitely this will be the usefulness. I thank our management for giving this opportunity for us to conduct this SSTP. I thank Dr. C.D. Naidu Garu, the beloved principal. I thank Dr. Chennakeshwara Garu, our beloved director. I thank our research director, Subhanandrao Garu, for his valuable speech. He has given a 10-minute speech on the applications of AI and machine learning. Thank you, sir, for your wonderful application speech. I thank all my colleagues, my senior colleagues, particularly Dr. C. Kirme Garu, or Dr. Mangatayar Garu and Mangatayar Garu, and all my colleagues who have involved and learned from all the knowledgeable sharing by the senior faculty from IITs, NITs, and all from industry prospect. I also outset thank all the participants. I heard that around 565 participants throughout the country, not only the country, from Malaysia and Bangladesh, few more participants have been involved in this STTP. Around 560 and actively participated around 250. So I think we are going to conduct series 2 also. Our strength is conducting these kind of STTPs and FDPs. So our faculty have been trained in IIIT, particularly Dr. D. Srinivasrao Garu, Dr. G. Madhu, Mangataru Madam, and few more faculty have been trained in higher institutions. And we have been using our course material from various reputed Coursera, Lycon. So it has been the strength for the department that the faculty are learning. And now we have to show in terms of application, we have to apply few projects, and then we should give some proper knowledge to the outside old participants apart from VNR Vijnana Jyoti. So this is how we are conducting from last 3 months. We have been conducting various FDPs, STTPs, seminars, and we have conducted conference also. Our CSC department has conducted conference on this latest buzzing words and on artificial intelligence, deep learning, machine learning, data science, etc. So at the outset, I thank the management for giving us this opportunity to conduct virtually this STP for 2 weeks in 2 series. I thank one and all for once again for giving this opportunity. Thank you one and all.
Thank you, sir. Thank you, Dr. G. Suresh Reddy, sir, for sharing your views about this STTP.
Revati, your voice is
Sir.
not audible.
Yes, sir.
Revati,
Yes, sir.
your voice
Sir.
is not audible.
It is audible,
Yes,
sir.
Yeah.
Yeah, I can go ahead, madam.
Yeah, okay, sir. Thank you,
Revati?
sir. Sir, I'm audible, sir. Yeah, I'll continue.
Audible to all other people except Suresh Reddy.
Okay. Thank you, sir. Thank you, Suresh Reddy, sir, HOD IT department, to share his views about this STTP. Now, it's time to propose vote of thanks. I would like to propose the vote of thanks to our funding agency, AICTE, for release of grant to conduct this short-term training program under AQIS scheme. I would like to propose the vote of thanks to convener and coordinator of this STTP. A leader is someone who creates an event. Team members essentially bring life to it. So no event can take shape without a hardworking leader. It was the dedication and enthusiasm of our convener, Dr. G. Suresh Reddy Garu, and Dr. Srinivasrao Garu, and myself. And your determinations are commendable, and it is your hard work which made this STTP a huge success. We extend our heartfelt gratitude to the trio. And it is time to propose the vote of thanks to our management, principal, and directors. A pessimist complains about the wind. Optimist tries to change it, and the leader adjusts the sails. The sails for this particular notion were adjusted by a person who is not only a great motivation to all, but a visionary and the person who gave us the belief to bring together this STTP. He is none other than our principal, management, and directors, Dr. C.D. Naidu Garu, Dr. B. Chennakeshwar sir, and Dr. A. Subbanandrao Garu. We extend our heartfelt gratitude to the trio. Now it is a time to propose vote of thanks to all the speakers. We would like to acknowledge our esteemed speakers who took the time out of their busy schedule and showered us with their pearls of wisdom and knowledge. Dr. Sita Madam, Dr. SSVN Sarma Garu, Dr. D. Srinivasrao Garu, Dr. S. Somaraj Garu, Dr. M.H.M. Krishna Prasad Sir, Dr. D. Ramesh Garu, Dr. Ailaya Garu, Dr. N.C. Naveen Garu, Dr. P. Rajendra Garu, Dr. Sanjeev Kumar Garu, Dr. C.H. Ramalinga Swami Garu, Dr. Mohanty, and Mr. Ramesh, and Dr. E. Damodar Reddy, and Dr. G. Madhu, VNR Vijayati. It is my pleasure, and we are truly humbled by your presence, sir. Thank you once again to all the resource persons. Now, it is time to propose vote of thanks to all the participants. Furthermore, let us have a special recognition to all the participants who remained patient throughout and encouraged the morale of the speakers by their gusto and enthusiasm. Thank you so much for being our pillars of the support. On behalf of our institution, we sincerely promise you that in the coming years too, we will keep on organizing this type of trainings related to the field with some more innovative ideas to nourish your mind and fill with you more knowledge. I shower my heartfelt gratitude to the professors and every one of the institution, our department faculty, network team for their wholehearted support rendered in the success of this valedictory session. Thank you one and all. See you next.
Just one, sir.
See you next week.
Jyoti, 1 minute. I will just take some feedback from the.
Yes, sir. Yes, sir. Yeah, we will open, sir. We will open for that also. We will open for that also, sir. Yes. Now it is time to share your views, opinions, and whatever you want to give about this STTP. Now the session is open for all the participants to give the feedback about this STTP. I request all the participants to unmute yourself and talk about this STTP, and you can share your views. Participants, do you want to share something?
Yes, ma'am.
Yes, sir. Please go on, sir.
Yeah. Yes, sir. Myself, Srinivas. Actually, I'm working here, Delhi NCR region. Okay. Actually, I didn't apply this program, but I got the mail because I attended the previous some of the workshop. But I am feeling it is a good opportunity for me by attending this session. It is one of the informative sessions, sir. I ever attended like this session, one systematic and the sequence of the topics, how exactly you are kept the sequence of topics. Actually, my field is also, I am currently pursuing the PhD. What exactly I want to learn within this short duration, I learned a lot. And what are the speakers you chosen? Really, those speakers are knowledgeable and you are taken from the IITs and NITs. Really, it is a great opportunity and I learned a lot, sir. And in future also, I'm ready to attend any type of session in your organization. Thank you, sir.
Thank you. Thank you, sir. Anybody else?
Hello.
Yes,
Hello. Am I?
Yes, sir.
Yeah, go on, Manoj. Go on.
Yeah. Sir, I am Manoj Kumar Chaurasia. I am working as assistant professor in Greater Noida Institute of Technology, Greater Noida. Basically, it is near Delhi, sir. Actually, this STTP was organized in a very well manner, and actually, I came to know about this STTP within just before 1 week before. So I was very excited, and I was searching for such type of FDP, STTP, like on machine learning, deep learning, and AI. So we were basically have some knowledge about deep learning, machine learning, but actually we don't have such depth knowledge. So that is why I was searching something to update my knowledge, to be even more clear my concepts. And sir, I would like to thank all the team that you have provided this kind of opportunity, not only me, but many more who were searching such kind of thing. So, and the speakers, basically, definitely, I would like to appreciate your team. That is very good team and very well coordinated and organized. But the speakers, you have selected your panel. That was extremely good. I have no words to say them thanks. That was basically their presentation, their knowledge, their expression, how to express their content. That was really, sir. I don't have words to appreciate, applause, but I can just only feel what I have got from this STTP. Thank you so much, sir, for organizing such an event, and keep on doing things so that we can get and update our knowledge. And in future, if you organize such kind of event more, like I came to know series 2, then sir, definitely inform us, and we will be waiting for that. Thank you so much, sir, for organizing such event and updating our knowledge. Thank you, sir. Thank you.
Thank you so much, sir. Thank you for your nice words.
Thanks.
As the time is reaching out, I request only one participant to share your views.
Yes, madam, I am Balaji from
Yes, sir.
Coimbatore. I'd like to thank the organizer for organizing this kind of event, STTP course. So in future, if we are organizing, inform me, madam. We will also organize. I will also again attend the same course. So it will be very much useful for the new learners. So that's what my feedback from attending the one week session, 1 week course. Thank you so much. Thank you for all.
Thank you, sir.
May,
Thank you all
may,
the. Yeah,
may
sir.
one suggestion, one thing I want to say.
Please.
STTP is excellent for if you are planning for the second session. Actually, sir, we are expecting some more hands-on sessions. In addition to the theoretical session, whatever this particular duration, the better the real-time implementation part. At least a morning session is a theoretical and afternoon session hands-on. That is the more effective way. What I am thinking. Whatever you kept, it is okay, but we are expecting more, some hands-on sessions. Okay, sir. If possible, you can keep, sir. Thank you.
Yeah. Sure, sir. Thank you for your comments and things which we need to be rectified and to be enhanced your skills. Thank you.
Thank you all the participants for your appreciation. Thank you all. And yeah, so it's a heartfelt gratitude to all the professors, to all faculty, teaching and non-teaching staff, and every one of this institution, our department faculty, networking team, technical team, all the faculty for their wholehearted support rendered in the success of this valedictory function. Thank you one and all. So see you in next series. Everyone have a good day. Thank you very much and have a wonderful and fun-filled evening. Thank you. Now it's time to open online assessment exam. So we are going to forward the link for online assessment exam now in the chat window. So this exam will contain 20 MCQs. So this form will be opened till 4 p.m. Thank you. Thank you all for your active participation.
And when you will provide the certificate, madam, for the course? When you will provide?
So once attendance and test performance is evaluated,
we
will send you the certificates.
Okay, sir.
Yeah, we need to summarize the attendance and as well as test performance.
Okay, sir.
Yeah.
Okay, sir.
And we will do it on
So there was network issues also. So please consider that also. So for few sessions, I couldn't attend these sessions due to poor network connectivity.
Yeah, we will look into it, sir.
Okay, sir. Please consider that also, sir. Thank you so much.
Dear participants, we have forwarded the link for assessment exam. Now the link is open. You can go on with your exam. It will be even posted even YouTube also.
Yeah, madam, we received it. Thank you.